Currently, when we talk about software-defined networking, we have two things specifically from the Cisco content point of view. We have actually two things. One is called like software-defined WAN, SD-WAN, and we have software-defined access, SD-Access. Specifically, we are talking about the enterprise network. In the enterprise network, we have these two things. From the certification, from the content point of view, we have software-defined WAN and we have software-defined access. For the data centers and all, we have like ACIs and all, we don't need to worry about. So software-defined WAN and software-defined access, these are two software-defined technologies that we see in our enterprise network. And Cisco has created the certification exams and they have also included it in the content as well. However, when it comes to certification exams, like SD-WAN actually is a dedicated certification exam. There is a dedicated content for the software-defined WAN. But when it comes to SD-Access, officially there is no certification exam for the software-defined access. SD-Access is basically part of the ccie, Enterprise Infrastructure Certification track. At the moment, currently, there is no certification exam for the software-defined access. There is a training available for the partners, clients, and those things, but that doesn't, concern us. That is not the part of our content. So, as for the SD-Access, at the moment, like if you go through the enterprise certification exams, tracks, and everything, you will notice that only for SD-WAN we have a certification exam, but for the SD-Access we do not have any professional or basic level of certification exam. Like, one is there, but that is for partners, clients, and those, that is from Cisco, like sales and those people, that is there. SD-Access currently is covered under the CCI Enterprise Infrastructure. So let's first see, as per the CCI updated content of the CCI Enterprise Infrastructure version 1.1. First of all, let's see what content we are going to cover in our software-defined access. Right, so this is CCI EI. Let me show you quickly. So from the certification exam point of view, just go to CCI EI lab exam, just click on the first link. It will redirect you towards the page where they have explained the topics. So CCI Enterprise Infrastructure version 1.1 practical exam topics. Scroll down, second unit, which is software defined networking. Click on that. It includes two things like SD-WAN and SD-Access. SD-WAN you can cover in a dedicated content, like there is a dedicated certification exam for the SD-WAN as well, and it is also part of our enterprise infrastructure lab exam. So it is also part of the SD-WAN is also part of the lab exam, and there is a dedicated certification for the SD-WAN as well. Right. So when you cover the dedicated SD-WAN curriculum, you no longer require to cover these things specifically, because all of these things are anyway covered in the SD-WAN topic, SD-WAN course. But when it comes to SD-Access, this is the thing, these are the topics that we will cover as a part of our content in the software-defined access. So Cisco software-defined access, the content is 25% in total. Software-defined infrastructure is total 25%. Half of it you can consider software-defined access, and half of it you can consider software-defined WAN. So under the software-defined access, what things we are going to cover? First of all, we'll talk about the underlying technologies used in the SD-Access, such as like Underlay. What is Underlay? How to create the Underlay network? What are different technologies to create the Underlay, such as like manual Underlay, creating the Underlay with the help of the LAN automation, how to discover the devices, different types of devices and everything. Basically, how to build the Underlay network. That will be either manual or built by the controller and all. So first thing first, how the underlay is built, and then on the top of that underlay, how the overlay network is built. So underlay and overlay is built with the help of the tunnels. Underlay is built with the help of the cables, protocols, and all those things. So underlay basically means like what cables, connections, protocols we have used to build our underlying infrastructure. Basically how we have made the devices reachable, and once the devices are reachable, we are going to build on the top of those devices, we are going to build some tunnels. So overlay tunnels with the help of protocol like Lisp, BGP, VXLAN, TrustSec, layer 2 flooding, and basic native multicast. So overlay and concepts related to the overlay, these like we are going to cover. So underlay and overlay, these are two technologies we will cover. Then what is a fabric? From the SDA point of view, what is a fabric? How can we design the fabric? like a single site fabric, multi-site fabric, how to connect those multiple sites with the help of the transit sites and all. So if we have like one site here, this is being managed by the SDA. This is an SDA branch, software defined access branch. Similar to that, we have this SDA branch, and there are a few devices here. There are a few devices here, and they want to communicate to each other. So how are we supposed to connect these two branches together? What are the options to connect these two branches together? Branch 1, branch 2, and if we have to connect the branch 1 and branch 2, what type of transit, what options we get when it comes to transit to connect these two branches? Right, so single site campus, multi-site campus, how to connect these two multiple sites together with the help of transits, what type of transit options we have. Then there is a feature called fabric in a box. Like we have a single device in one branch, we have only one switch, only one device. So how can we build our fabric on the same device? In one device, how can we build a fabric? Like what options we should set to build the fabric in single device, which is like fabric in a box feature. How can we build a fabric? How can we build a fabric in a single box? That we will talk about. So this is like third thing focuses on the fabric design. How can we design our SDA fabric? Then once we have gathered all the things that we required to build the SDA fabric, then we will build the SDA fabric. We will talk about like how what are the options once we have connected all devices together, then how host onboarding is done, authentication template, configure the port, how to connect the borders that connect multiple sites. So here is a device that connects one fabric with another fabric. So how to connect these, how to configure these borders so that multiple fabrics can be connected together. How to configure, if we have multiple devices, then how can we set the priority for that border? Then how can we add the device to the fabric? Basically, once we have decided how we are going to build the fabric, then we are going to build the fabric and everything related to that particular fabric. And then handoff. Handoff basically means like here we have our traditional network. Here is our data center running on the traditional network. We have traditional routing and switching going on there, and there are certain prefixes like XYZ. These prefixes are getting advertised to our SDA branch, and we also have like SDA prefixes ABC. These prefixes are there in the software defined access branch. So how the handoff, how like these prefixes will be handled by the SDA and how the SDA prefixes will be handled by the traditional branches. That is what we refer to as the handoff. Like what are the options available for the handoff purpose? How can we advertise the prefixes from like non-SDA branches to the SDA branches, SDA branches to the non-SDA branches? How can we control the propagation of the prefixes and everything? That will come under the handoff concept. There is this thing called layer 3 handoff. There is also this thing called layer 2 handoff. We'll talk about both of the things. We will try to implement both of the things. At least L3 handoff we will be able to do. Then we will see if we have the options. Then we will also do the layer 2 handoff. Layer 2 handoff basically handing off the VLAN. There is a VLAN that is part of a traditional network. There are some users in that, and this is one department, let's say HR department, and same users, same department users are also available in SDA branch, and we want these users to communicate with these users. But here we have a traditional VLAN, and here we have like the VLANs created by the SDA. So how we are going to map these two VLANs together, that will come under the layer 2 handoff. Layer 2 handoff basically means handing off the VLAN to VLAN, like how a particular user in a VLAN in a traditional network is going to communicate with the users in the SDA network. That will be like L2 handoff. So L3 handoff and L2 handoff, we will talk about that. What is this fusion router? How this fusion router is configured? What is layer 2 border handoff, layer 3 border handoff, types of transit and everything. We'll talk about that. And then finally, security. Like once we have built our fabric, once we have onboarded our devices, once every device got the IP address and everything, and then we want to enforce the security. So how can we integrate our identity services engine, and how can we create the policies on our identity services engine, and how those policies are going to be evaluated by the switches to control what two devices can communicate and what two devices cannot communicate. So micro segmentation, macro segmentation, whatever these things are. Basically, segmentation means like allowing two devices to communicate or restricting two devices from communicating to each other. So that thing we are going to talk about under segmentation. although our content is only this one, this is what we are going to cover as a part of our content, Cisco Software Defined Access, Cisco SDA. Although our content only focuses on these things, underlay, overlay, fabric design, fabric development, deployment, then border handoff, segmentation. Once these base topics are done, once we are done with these base topics, we will also talk about a little bit about the wireless technology, like how can we have wireless access point, WLC, fabric enabled access point, fabric enabled WLC. How can we onboard our APs? How can we onboard our access point in our SDA? And how can we manage those APs with the help of the WLC? How basically WLC communicates with our SDA, DNA Center controller and everything. So at the very end of our content, we will also talk about the this wireless topics. A little bit of wireless we will also cover at the very end. Like at least we'll talk about the WLC onboarding, how WLC connects with the controller, and how APs join our SDA, software defined access branch, and everything, how the tunnels are formed and everything, how the traffic is sent from one device to other device. That thing we will talk about at the very end in our wireless content. So it will be a mix of both wired and wireless. First we will cover our wired content. Once the wired content is done, then we will also talk about at least a little bit of wireless as well. Even though wireless is not part of our content, but since there is no dedicated certification exam, we are not sure like how much we should cover. So we will talk at least a little bit about the wireless from the AP and WLC point of view. We will create some SSIDs. We will join, like we will let some users join the wireless network and all, and then we will try to ping and trace and see if the traffic is going through or not. We will apply the policies and everything. So we'll take like at least like 2-3 classes for the wireless as well, so that you know the wireless onboarding part as well. Right. So from the content point of view, that's what we are going to cover. Again, repeating myself that there is no dedicated certification exam. There is no dedicated certification exam for the software defined access technology, not at least yet. So SD-Access currently is covered under our ccie enterprise infrastructure curriculum. So this is the content that we have to focus on from the exam point of view, and currently at the moment from your production point of view. In your production network, they might use more than these things, but at least these things we should focus on from our content point of view. And then of course some wireless, some we'll also at the very end we will talk about some APIs at the very end. Again, not in detail, but we will see how can we use a variety of API calls to do the same things using some tools such as Postman and everything, not doing everything from the GUI. So that thing also we'll cover, but at the very end. We will focus on these things that are right in front of you, and then additionally, such as wireless, a little bit of like API calls and everything, we will also do at the very end. Right. So this is the content, and this is the document that we will actually use to cover that content. We'll talk about like why we need software defined networking, what things are there in the SDA, SD-WAN, what is software defined networking, what is the overall solution for the software defined networking and everything. And then from the architecture point of view, how to build the SDA network and everything. So you will see like all the things that we have talked about will be covered from this PPT, these PPTs.
Surendra,
yeah.
My name is Irshad. Okay.
Yes.
So just sorry to interrupt you. I have one doubt here. Okay.
Yeah, sure.
Yeah, that's like you told, we don't have exam. So
Yes.
do we have any virtual environment on this? Can we do lab from in our personal laptop, like we do?
Not exactly. Let me brief you on that as well. That was our next point. Let's discuss about the lab now, right?
Okay.
So the point is that since these software defined, there are, just to brief you, when it comes to software defined access technology, like we require a few basic things, such as we require switches, and these switches must be like SDA compatible switches. Then we require a controller, that controller which is responsible to manage these switches from one centralized point, also referred to as our DNA center or catalyst center. They have renamed it. So catalyst center controller. So like so far, like we only had the like if you want to build the labs and everything at your home environment, you will require like physical switches that have the SDA compatibility, that have the SDA capability, I would say, especially like those 3850 series switches, 92, 93, at least 9K platforms, 3650. Those switches you will require. Physically, you will require those switches because those switches come with the necessary hardware actually to support the SDA. And then you require the DNA center. Again, DNA center is also at the moment. DNA center is also one hardware appliance that Cisco sells, and you have to purchase that hardware appliance. There was no software image for the same. Recently, Cisco has launched that DNA center virtual appliance. DNA center virtual appliance. That virtual appliance you can either host on the cloud like AWS, or you can deploy it in a virtualized environment such as ESXi. Even then, even like they have launched this DNA center virtual appliance, there are nowadays, if you go for that CML Cisco modeling lab, they have their own EVNG type tool, like CML is tool from Cisco itself. So they do have some images for like switches that support like SDA, like those 9300 series images. Like there is at least 9K image actually available that is actually supported of the SDA. But even then, like nowadays you do have all these resources, but still, if you want to build a full-fledged lab, you will not be able to do it like in your I would say laptop, because for example, to run one of this switch, single one of this switch, if you want to run one of this switch, actually you will require at least 24 gig RAM for one switch, and at least, as per they say, if I'm not wrong, 4 cores are required, right? And in our deployment, at least we will require 2 branches. At least we will require 2 branches. In one branch, we will have 3 switches. In one branch, we will have at least 1 switch, so that we can see the fabric in a box feature. So at least, like minimum, you will require like 4 switches. Then you will have some traditional network and everything. So the amount of resources that will be required to build a lab at your home environment is very high. Also, don't forget about the DNA center. You also require the DNA center. DNA center, the virtual appliance that they have launched for the DNA center, it requires, if I'm not wrong, it requires like approximately 50 to 60 cores in total, and 250 or 256 gig RAM. So anyway, like it's basically not feasible for you to, it will not be feasible for you to build the lab at your home environment until you have a very good resource, very high end server. Even then, if you have like very high end server, you have to download the images, you have to download the DNA center virtual appliance, then you have to deploy it. The DNA center virtual appliance will check the throughput, SSD capabilities and everything. Even then you will face plenty of problems. So in short answer, basically at the moment, it's not possible to build a home lab based on this DNA center virtual appliance and the switches actually. That is why what they have done actually, on the cloud itself, you can just you can just take the benefit, like all the things that that we will be doing in our classes, all those things actually, all those things you can not all, if not all, basically almost all of those things you can practice on this D-Cloud DNA center. There is this thing called sandbox environment. Cisco also has this sandbox environment where you can schedule the lab. You can schedule the lab for the later days, and then you can, once your once your it's your time to access the lab, then you can just use the VPN software and you can access that lab and you can do the practice on there. But I have heard that this sandbox environment does not work well. So to explore almost everything that we will be doing in our classes, almost everything you will be able to explore in this D-Cloud DNA center. It is completely free. Later on we will talk about like how can you access this like DNA center, D-Cloud and all. I will show you how, whatever things we will do in our home environment here in the classes, we'll see how can we do those things on the D-Cloud DNA center there as well. So the point is that at the moment it's basically not possible for you to build the lab at your home, but it will be possible to explore all the features that we will talk about as a part of our content D Cloud DNA Center, right? Again, not everything, but almost everything, like you will be able to do from the exploration point of view. You will be able to do it from here. Right? This is the demo. You can explore all the options. Like this is, I guess, like some old version, but you can explore all the options that we have here. Right? You can, in fact, you do have the read access as well. Like write access you have, you also have the read access. So, for example, you want to do some changes, you can do the changes in this Cloud DNA Center. There are like already a few sites created, there are already devices available and everything, so you can explore a variety of options, plenty of options from here. Of course, here in our premises we do have some some physical switches. Like we have three 3850 that we will be using. We have more than that, but three 3850 we will be using, and we have one 9300 series switches we will be using. We have like one DNA center here that we'll be using, and I will be doing everything, and then I will be using EVNG. In the EVNG, I will build my traditional network, and I will connect this so that we have some subnets here, and I will connect this traditional network with our real, like SDA branches and everything. So here on the premises, we'll be doing the things on the real devices. Once our classes are done, you can just on regular basis, whatever things we cover, you can just see what topics we are covering. You can revise it from the recordings and everything. You can make the notes if you want to, like from the lab point of view. You will also have like all the recorded sessions and everything, but still, like if you want to make some steps, like if I want to do this lab, then first I have to go here, then here, then here. You can make the labs and you can make the notes and everything. But later on, like once our classes are done, like once we are done with the classes, then it might be possible for us to give you the lab access over the VPN. But during the classes, since we have like this single set of resources, if I give you the access, then I will not be able to do the labs in our upcoming classes and everything. I have to set up everything from the scratch. So maybe once our classes end, like at the very end of our classes, then at the very end we will be able to give you the access over the VPN, so that you can test all those things that we have studied in the classes from your side as well.
At the end means, do you want to mean after finishing of the course?
Yes, no, after our content is done, after our SDA classes are done, once we are done with all these practical topics, basically when these switches, these DNA center is completely free from our training sessions, then at the end, like we might be able to give you the access over the VPN. But during the training, I think like it might not be possible, as you might have already instructed from the management side. But at the very end, we will be able to provide some time-based sessions to candidates. At the end basically means like the end of our classes, at sessions, like once we are done with our SDA classes, then at the end, like you can revise the classes from the videos, and then you can do the labs based on the same. It's at the moment it's basically not possible to build the lab at the home environment because of the resources that it requires. Even though there are virtual solutions, but they're not very feasible.
Surinder, this is Prabhakar.
Yeah.
So will you cover like a deployment and 2+1? There is some conditions, right, to deploy the DNA center.
The installation point of view, no? From the installation DNA center installation point of view, right?
Correct.
Yeah. We will cover it. Yes.
On evidence node.
See what we do actually when we start our specifically DNA center topic. Then we talk about like how from the day zero point of view, you get a DNA center appliance, and there is an ISO image that is there. Then I open the official document from our Cisco website, and then I will go through it. Like these are the steps that we are going to take to deploy to install that image on the DNA center. But we will not do it practically because it takes too long. It will take too long. I will show you all the steps that are required to install the DNA center image on the DNA center appliance. I will follow the document, and I will show you like, okay, these are the interfaces available: enterprise interface, internet interface, management interface, all the interfaces, we will talk about that. Then how the installation is done, what settings we need to do, what subnets are required, everything we will talk about that. But it will not be possible for me to do it practically because we already have DNA Center image running on the DNA Center appliance. In that case, I have to wipe it completely, then install it. It takes like too long. The installation takes like first the DNS Center image gets installed, then updates gets installed and everything. So I will be able to brief you about the steps and everything, but practically, like, I will not be able to show you that.
Yeah, I agree. No, what I'm asking, like one active passive, one evidence node, like that, no?
The HA, right?
HA.
We will discuss about HA again. Same thing. Theoretically, we will be able to discuss it. Like, how to set up like two DNS Center clusters and have the witness site or the evidence site. Yeah. So yeah, we will talk about it. Definitely.
Okay. Please just explain us this upgrade.
DNS Center upgrade options.
DNA plus switch. It's end of the sessions. Just give me some brief or overview.
No issues. Done. No issues.
Yeah,
I will be able to show you. Yeah. No issue. I will brief you about the upgrade and the upgrade of the DNS Center and the switches. Definitely.
Okay, thank you.
Not a problem. That can be done.
Hi, Surinder. Good morning, Lakshmi Narayana here.
Yeah, hi.
Yeah. I just want to ask you two questions. Like one thing, like in this course, like we are going to discuss about this Lisp BGP versus Lisp PubSub.
Yeah.
Because Lisp BGP is earlier concept which we will use for control plane, and Lisp PubSub is the new concept, right? So we are going to discuss about this.
I will again, since I will be able to discuss it. Of course, we will be able to discuss all the transit options: SD-WAN transit, then SDA transit, and then the traditional transit, IP-based transit. Like, we will be able to discuss it. But as our content focuses only on the IP-based transit, right? We will practically implement only IP-based transit. But in the D cloud itself, like, I will be able to show you how that PubSub concept actually works.
Okay, and one more question, like when we are discussing about multi-site concept, right? So we are taking two fabrics and one non-fabric site. But my question is like whenever some people from non-fabric site comes to fabric site to join, I mean, how they will join the network? This kind of use case will be discussed.
Yes.
Okay.
I do have a topology where we will have like our data center running on the traditional network, right? And then we will have two branches that will be running on the SDA network, and we will export all the SDA to the SDA prefixes to the traditional to the SDA with the help of some concept of that VRF, RD, RT, those things. We'll do that. We'll see how the communication actually happens.
Okay. Thank you.
Right. Again, like, just to brief, like our content is going to, our whole discussion will be more focused on the content. Like, it will be content specific, but here and there we will definitely go through like other topics such as, for example, HA, high availability, how HA is achieved in the DNS Center deployment. Then again, when it comes to Lisp VXLAN, it's not like we are going to cover everything about the Lisp and VXLAN. We will cover only those things that are needed in our SDA deployment. You will get the basic fundamentals of the Lisp, you will get the basic fundamental of the VXLAN, but it's not like we are going to practically like manually going to we are not manually going to configure the Lisp and VXLAN. No, those things will you will be able to cover in the data central track and all, but we are not manually going to cover like Lisp and VXLAN. Since these two things are more like, I would say, automated from the DNS Center. So like when we build the overlay network with the help of our controller is automatically going to push the necessary configuration about the VXLAN and the Lisp. So we need to have the fundamental understanding of the Lisp and VXLAN to understand like what configurations are pushed. ISIS also, there's also like, do they have ISIS? ISIS is also there. It's not like we are going to cover everything from the ISIS protocol point of view, but we will just talk about like what is ISIS, how the ISIS neighborship adjacencies are built, how the DNS Center is going to use the ISIS. We'll talk about all that. But again, do not expect that you will have full-fledged understanding of the VXLAN, Lisp. That is more like a data center part. Since the advantage, that the term, the software-defined networking, the term SD, software-defined basically means like it is the responsibility of the software to do all the necessary configuration to build the overlay network. So we just need to have the basic understanding of the Lisp, VXLAN, and in fact the ISIS protocol. We will discuss about it. If you see from the slides point of view, we will, when it comes to like SDA here, right here, when it comes to SDA overlay, we will talk about Lisp, VXLAN, TrustSec, like what is Lisp architecture and all those things, SDA control plane based on the Lisp terminologies and everything. We will have like I would say a little bit detailed discussion about the Lisp and VXLAN, but it will not be equal to the discussion that you have in the data center or the other tracks, right? So just whatever is necessary from our content point of view. That's what I'm saying. Again, whatever things are possible to do in the lab, I will show you in the lab. Whatever things are not possible to do in the lab, for example, such as installation of the DNA center, more like you just purchase the DNA center appliance, and that DNA center appliance comes with the along with an ISO image, and you have to install that ISO image. Now that it is not possible for me to install that image, so what I will do, I will basically show you like how that from the document that they have provided, I will show you what steps are needed, how to connect, how to provide the connectivity and everything, and then we will actually I will show you the commands and everything that are required, and then we will begin. We will assume that our installation is done, and then we will move on to the configuration part. Right. So again, our discussion of the software defined access is going to be more content specific, right? So from the underlay, overlay, whatever it is, and then of course like ICE, wireless, AP, HA, installation, multicast, those things will be covered additionally as a part of our SDA discussion. SDA is basically just this, if you go to the DNA center, just go here, and SDA is just this, like this is SDA, this is your SDA. This is what we have to focus on actually. This is just what we have to focus on actually. SD-Access is more like something that we manage, that we create, that we build our fabric, manage our fabric, underlay, overlay from our DNA center appliance. DNA center has tons of options. This tool, this controller that we have, known as the DNA center controller, it has like a lot of options. It has the option from the wireless point of view, wired point of view, security point of view. But since our content specifically says SDA, we will focus more on the SDA part of it rather than focusing on each and every. Do not expect that we will talk about each and every tab. I will just give you the overview, but do not expect that we will talk about each and every tab that is available in the DNA center. Again, as much as possible, we will discuss it, but it will not be possible for me to cover each and every tab and go through all the options. From your production point of view, later on, when you require to create, let's say, for example, a site-to-site VPN between two sites, you can just go to the site-to-site VPN option, and you can just explore the options by yourself. Our content does not concern it. Again, whatever things are there in our content, we will focus more on those topics, and later on, if some time is left, then we will be able to explore other options. Yes, PNP we will cover. It is part of our content right here. I will show you how PNP works actually. PNP and LAN automation both, we will talk about it. I will practically show you how that works. Again, whatever things are possible for me to show you practically, I will definitely show you practically, but there will be a lot of things that we might not be able to do from the practical point of view, such as HA, high availability, installation of the DNA center, multicast we will be able to do, no problems. L2 handoff might, we will talk about it from the theory point of view. Lisp pub sub, those options we will talk about from the theory point of view. I will show you the lab on here itself, like AP WLC onboarding we will do. We will see how AP onboarding is done, how WLC onboarding is done. But it will not be possible for me to go through each and every option of the WLC and tell you like, okay, how roaming is done and how those, like, that is wireless. So our topic is integrate wireless with the SD integration with the wireless, or from the ICE, for example. We're not going to talk about like each and everything about ICE. We will see how ICE is integrated with the DNA center and how can we create the security related policies from our DNA center, right? But again, for that, we are not going to jump on the identity services engine. we will not go through each and every option of our identity services engine. We are just going to explore basic options from there. Whatever is necessary, we will talk about it. Right. So let's be very clear on the expectations. Like this, these are the things that we will cover. Again, these are all the topics that we are going to cover, and plus wireless, plus AP, plus installation of the DNA center, plus like all those additional things that we have talked about. I guess like you will have a pretty good understanding of the DNA center and the SD options available inside the DNA center once our complete discussion is done. We will be using DNA Center version 2.3.5 if I'm okay, right. Like I have not checked the version like since the last class, but 2.3.5 or 2.3.7 is the version that we will be using actually. Again, when it comes to lab, at the moment, like along with the classes, it might not be possible for us to give you the lab. Once our classes are done, then at the very end, it will be possible for us to give you the lab access over the VPN. You can have a discussion with Mr. Saurabh, Sugan, or whoever is in your contact. You can drop in them a message. How can we access the lab and everything, and they will brief you on the same. Right. So at the moment, you have to focus on whatever we are doing in the classes. Again, what on day-to-day basis, whatever things we are doing in the classes.
Sir, excuse me.
Yes.
Sorry for interruption. What you have said to discuss with Mr. Saurabh and Sugan?
Once our classes are done, once we are done with our classes, then you can ask Mr. Saurabh and Sugan, how can you get the access to the lab? Or you can have a discussion right now after like our classes end. Then you can have a discussion. How can we get the access to the lab? They will brief you how can we access the lab. It will not.
Sir, I'm also have the access on the previous lab which I done under your SD-WAN courses.
SD-WAN will be there. Like SD-WAN will be there, but for the SDA, since we require physical resources and everything, along with the classes, it will not be possible for us to give you the lab access.
Okay, so got it now. Thank you.
Right. Also, coming to the point of prerequisites, what things you need to know before you you start with the classes. Although like there is no very not a lot of things, but the main thing is that you should be clear with the basic switching, how to design the switch the campus. That is one thing, although we will talk about it, but you should have the basic understanding of the switching. Then when it comes to routing, you should know a few things about BGP, Border Gateway Protocol, because BGP is what we will be using in our handoff. Again, I'm not saying that in and out you should know complete BGP. At least you should know what is AS number, how the BGP neighborship is formed, how we can advertise a network. Those basic things, like just like from your EIGRP OSPF point of view, basic routing. What is routing protocol? How to what is AS number? How to advertise a network using the protocol and everything. Those things, the basics you should know from the BGP point of view. And VRF, virtual routing and forwarding, because when we talk about this handoff concept, when we have to exchange the route from the traditional to the SDA to the traditional branches, the concept of handoff requires the use of VRF. So you have to have the understanding of the VRF as well. We will talk about it, but again, if you have some previous understanding of the VRF, it will be good. What is this VRF? Route target, route distinguisher, import, export. Although we will talk about it, but it will be good for you to at least revise it or just go through some videos on the same topic, VRF, and what is this RD, what is this RT. Although we will have a discussion, but not in very detail. That thing from the routing point of view, at least you should know. No need to worry about IS, no need to worry about like EIGRP, OSPF, not like a lot of details from those protocols will be required, but here at least the basic understanding of the BGP and like a little bit understanding of the VRF from the handoff point of view will be needed.
So Surender, from the underlay perspective, the lab is set up on BGP protocol?
No. We will set it up completely fresh. So
Okay.
when we use like first we will talk about this LAN automation feature. In that, DNA Center will build the underlay automatically for us. That will be based on IS. And then we will see the manual underlay. Manual underlay, we will use protocols such as EIGRP or OSPF, whatever is useful. Then when it comes to handoff, then we will use BGP.
Okay.
Right. Similarly, like when we talk about like security, although we will talk about it, but again, like I said, I will not go through each and every option of our identity services engine. So if we have a little bit understanding of what is this ICE identity services engine, what are variety of options, we will cover only what is required as per our content. You will not require a dedicated identity service engine classes, not at least from our SDA content point of view. But again, if you have the knowledge of identity service engine, where like you know the options, like how to create the policy, how to create the users and everything. If you know those options, it is good actually. It will be more like more like an advantage. It will be from our lab point of view, because when we do the lab, I will just go through the ICE. I will show you like, okay, here is the option, here is the place where we create the user, here is the place where we create the policy and everything. And I will tell you what is authentication, authorization, accounting and everything. We will just go through the basics, because only basics are required as per our content, right? So if you have already covered it, then it's okay. If not, then at least the basic of this security product, identity service engine, you should know like what is ICE, why we use ICE, what is AAA, what are the functions of the AAA, what is this radius, what is this TACAX. We will talk about it as a part of our content, but only basics. Do not expect that we will have in detailed classes for the identity services engine. Same goes for wireless. When we talk about the wireless content, I will assume that you know what is an AP. I will assume that you know what is a wireless LAN controller. I will assume that you know the options, like how the traffic moves from the AP to the WLC and those things. The basics of wireless. I would say the basics of wireless, I will assume that at least you know. Although we will talk about it, the deployment methods and everything, but I will assume that at least you know from the basic of access point and wireless, the LAN controller, WLC point of view. I will also, before our class of like wireless begins, I will also refer you some videos that you can take a look before our class starts, so have the understanding of the AP and WLC. When our discussion of security will be there, then I will share a few videos from the YouTube, and then you can refer to those videos. You can just watch the videos before our class, so that you get some understanding of the ICE, AAA, radius, the CACs, so that you can understand the things that we will discuss in the classes. When we start our BGP, I will share you a few BGP videos, some VRF and those things. So even if you are not like completely aware of these things, at least if you have basic understanding, it will be sufficient. These are like basic, like it is not a fresher level course. Actually, that's what I'm saying. It's not like you have to have some understanding of the basic network. Then it will be much better option to go through all these SDA topics. Right? It's a professional level course, as you know. It's not a associate level course. To at least some basic understanding of the networking you will require. Again, the basics, not the very expert, not the very professional level, but the basics things will be required. And definitely we will when we start one topic, we will definitely at least we will touch the topic of AAA, ICE, AP, WLC. But again, do not expect that we will have it in A to Z complete detail. That does not concern us. For example, ICE, there is a dedicated track of ICE in security. So if you want to know in and out of ICE, you can complete that dedicated track of ICE, which is a professional level certification exam. in your security. For the wireless, we have ENWLSD. There is a dedicated certification for the wireless as well, wireless design and wireless deployment. So again, from our content point of view, we will just test those things, and then we will move on to our content specific discussion. Right. So if you think like these, the topics that we will be covering in our content is useful to you, then definitely like, you will get a lot of benefits from the content. Else, like you can have a discussion. If you have like some other expectations, then you can have a discussion with again Mrs. Saurabh and Sugan, and then they will brief you what things we can do and what things at the moment can't be done. Right. So like this is all that from the lab, from the content. The books are also there, just in case. This is the official book actually. I will not say a certification book, but this is the official book that we have to go through. If this is the official book for the SDA, software defined access, that you have to go through. This book will be uploaded onto the portal. Like, this is the official book for the software defined access. Like that you have to go through. This book briefs you on the topics required to know. These are like chapter 1. A lot of theory is there. Again, not everything you have to go through from it, but it's a lot of theory. Like first of all, like what is today's network? What are the challenges in today's network? Then what is software defined networking? Then what is this DNA center? Then what is this SDA? Then what is this identity services engine, Cisco identity services engine with the DNA center? How ICE basically integrates with the DNA center. Then they have this option of like VXLAN, list, BGP, basically the SD operations and everything. Then advanced DNA center topics such as different types of nodes that we can have, multicast and everything. Those things cover under transits. Those things cover under the advanced SDA topics. Then we have like advanced DNA center features such as like cluster and everything. How can we manage the software images, upgrades and everything? How can we do that? Those things are templates. Those things are basically advanced DNA center topics. And then monitoring. At the very end, we have the monitoring topic. So 9 chapters are there. These 9 chapters are basically sufficient to give you complete idea about the SDA and the DNA center, at least from your production point of view. Again, if you want to go through like not in that much detail, just want to get the idea, then we have another book. This is like, this book actually is, this is more like cut to cut topics, like, whatever things are necessary only, those things are there. Like, this is more like a redefined version of the same book, but it is more like here in this book, it's more like cut to cut discussion about the topics. Right. So this is also one book that you can refer to, which we will go through it. But they have talked about in this how can we do the deployment and everything. Not a lot of chapters are here, but again, like what is SDA? SDA overview, then components one by one, how fabric operates and everything, and what is DNA center? How can we configure the policy? What is automation and assurance? Done. So this is more like brief cut to cut book that we have. This is not the official book. This is the official book, but you can also go through this document as well for the discussion. There's also one more book actually that I have. You can also refer to that book. There are like plenty of books, like 2-3 books are there that will be sufficient, enough for us to basically give the idea about the DNA center. Let me. Where's that book? Let me show you the last one as well. And again, all these books will be uploaded onto the portal. You can download these books from the portal and you can refer to these books directly. And there's one more, like, that is more like updated one. I had that downloaded somewhere. It's there. Not sure where it is. I will upload it. I have that, that updated one somewhere. I have that book actually. anyway, so there are these 2-3 books that we will actually go through, and these topics within these books will be sufficient enough to cover everything from our content point of view. If you want to get the brief, you want to get like if you want to know about the DNA center controllers and everything in brief, this is good book. And if you want to get through it in very detail, then officially this book is there. So we'll go through all the topics and everything from both of the book from our content point of view.
Saurav sir.
Yes.
Sir, there are another 3 books also in our course content. One is SD-Access Wireless Design Deployment Guide.
Yeah. Those are the things like you can refer to those deployment. There are plenty of documents available, like deployment guide is there, migration guide is there, troubleshooting guide is there, command guide is there. There are different actually documents there available. So you can again like let's say for example in your production environment you are going to deploy the DNA center, or you want to migrate from the traditional to the DNA center. You can refer to that book particularly, that deployment guide you can refer to, or migration guide you can refer to see variety of options, variety of scenarios they have given in that. You will follow a particular scenario when it comes to upgrade, or installation and those things. So that is from that point of view. Those books are like from the point of view of the upgrade and those things actually. So yeah, we do have other books as well. Again, everything, all the documents and everything will be uploaded onto the portal, and you can definitely download all those books, or you can just Google it. You will get it from there as well. Here is the one that I'm talking about. This is one more document. This is one more book actually that we have. Let me show you. Here, a software defined access for the distributed campus. This is deployment guide. This is specifically deployment guide, like how to deploy the. Again, they have briefed what is DNA center, what is SDA, transits, and everything. This is also one very good book actually that you can go through. Different scenarios are there in this book, like when we have to migrate from one to another and everything. So again, all these books will be there. You can refer to these books as per your requirement to get more details about the topics that we cover in classes. Right? More questions, let me know. By the way, we will have 3 hours classes. So we will have one session, from 9 to approximately like 10:30. Then we will have a short like 15-minute break in between. And then we will have our, you can refresh up a little bit. And then from 10:45 to 12, we will have our more like second session. Or, we will like maybe 11:45. So last 15 minutes, we can have Q&As. In between also you can have the Q&As and all, but we can have like last 10-15 minutes to have the Q&As and everything as well. Right, so we will have like the classes in 2 sessions, like 9 to 10:30, and then we will have a short 15-minute break, and then we will cover from 10:45 to like 11:45, something like that, and then we can have Q&As and those things. Let me know any doubts from the content point of view, from the lab point of view, from the document point of view. Even this PPT will also be uploaded onto the portal. You can refer it from day-to-day basis, on the day-to-day basis, to revise everything that we have. Videos will also be there onto the portal, so you will get all the documents, all the videos, resources from the portal itself. Still, if you have like any doubts, let me know. Any questions? We have to be very clear on the content that we will be covering. If you think this content meets your expectation, then you can definitely like continue with this.
Hi, Surinder. Yeah. With respect to like this course, especially for SD-Access, this is exactly for campus network automation, correct?
Yes,
only for the local area, correct? Not for the
yes.
correct?
Yes. From the when we talk about like the transits, we will have a discussion about the SD-WAN based transit. There we will talk a little bit about the WAN, but this whole course will be focusing on the LAN part of it. Yes.
Okay.
Right. Maybe I will show you a scenario where we have used our SD-WAN as a transit to connect multiple sites together. I will show you a few
for today classes,
topologies based.
we will
Sorry?
start from for today class. We will start from the scratch, or it will be from.
Yeah. Completely scratch. Nothing will be configured in our DNA center, in our switches. We will start completely fresh. Everything from the scratch.
And like what I read, like if we want to upgrade the switches, normally we do from SolarWind or from TFTP or from USB or from FTP. So from DNA also we can upgrade the switches.
Yeah, we will talk about that under the software repository, SWIM, software image management option. We will talk about that under SWIM option that we have. Definitely we can do that. We can do the software
So
upgrades from
that
the
is
DNS.
totally automatic, correct? That is nothing we need to be monitoring, or it will do everything automatic. That is my
It will do it automatically. However, if any error comes, then you have to check that error and resolve the error as per your knowledge. In certain situations, like you will notice that errors occur actually. So if some you will download the image from the Cisco website, you will upload it onto the DNA center. DNA center will push the image onto the devices. It will do the upgrade and everything, and it will be automatic. But the point is that if any error occurs during that upgradation and everything, then you have to in that case check the logs and try to rectify that problem. But rest will be automatic.
Okay.
So the DNA and the Cisco Prime is the same, or is a different?
No. Cisco Prime infrastructure PI was the solution that we were selling before the DNA center came into the market. Now more like the Prime infrastructure is more like being replaced by the DNA center. So they also have a guide on how to migrate from the PI to the Prime infrastructure to the DNA center. So it's more like an upgraded product that they have. Before it, we were using this Prime infrastructure. We'll talk about the options that we had as a part of our content as well. Prime infrastructure was something that they were offering before it, but nowadays DNS Center more like has or it will sooner or later will replace the Prime infrastructure solution.
Okay.
So with respect to the WLC, whether that is a 9800 or 5500 controller, it's a physical, or
no 9800 CL cloud one.
Cloud one, not the physical one, correct?
No, we don't require it actually. 9800 CL will work fine, and we do have some 9100 series 9100 AX series APs in our environment. So which are compatible with the SDA. We will be using those. I do have switches that run on the WLC, that can run WLC on the box itself. So like those 9300 series switches can run WLC on the box itself. So we just have to download a package and upload that package, install that package, and the switch itself will start acting as the WLC. Correct, but for the sake of our content, we will have 9800 CL, so, completely from scratch. We will set it up.
Okay. And for all these like all these switches which we are managing from SDA, they should be stacked. All these
no, standalone switches. Stack, if you want, we will talk about it. But these switches will be like standalone switches. These are not stacked.
Okay. Thank you.
Sir, this course will cover the CCI enterprise SD-Access topics, right?
Yes. It will focus specifically on those topics plus additional content such as wireless, AP, WLC, a little bit of security and those things. Yes.
Okay. Thank you, sir. No problem.
Right. More questions? Let me know. Any more doubts if you have? Right. So the main thing about the software-defined networking. What exactly is software-defined network? Software-defined network, or SDN, basically a type of network where a piece of software actually is responsible to manage, configure, manage, monitor the entire network solution. So the term software-defined networking, or SDN, basically it says that instead of doing all the manual configuration, instead of doing manual onboarding, monitoring, and everything. Why don't we use some software to do all that configuration, provisioning, monitoring task? So use of a software to manage the network, like use of any software to manage the network, that is what we refer to as the software-defined networking. With the help of the software, we are managing the network. That is basically that refers to as the software-defined networking. Now, these softwares that we have, these softwares, software-defined networking, these softwares which are responsible to manage the network, these softwares are typically referred to as these controllers. So instead of saying that software-defined networking, in SDN, we use a software to manage the network. We typically say that we use some sort of controller to manage a network. Now, controller is basically a piece of software. Eventually, it is a piece of software that is installed on some hardware. If you have a software, you have to install it in some hardware. So let's say we have a dedicated server. In that server, we have installed that software, which is responsible to manage all the resources, all the network, that hardware, that product is what we are going to refer to as a controller. So controller more like is a component of our software-defined networking, which is basically responsible to manage the entire network from the centralized point. Typically on this controller basically is a software running on the top of some hardware. This hardware could be anything, could be a simple server offered by other vendors, server offered by the Cisco, whatever it is. Eventually, it's basically a software. Eventually, it's all a software thing, a piece of software responsible to manage the entire network. That is what we refer to as software-defined networking. Now, where we have installed that software, we have installed that software on some sort of hardware. That hardware could be a server. It could be any like physical server, virtualized environment, whatever it is. So that hardware where we have installed that software is in short what we are going to refer to as the controller. So controller is a piece of software. Controller is a component of our software-defined networking, eventually responsible to manage our entire network from one centralized point. Now, different products are there when it comes to software-defined networking. Different vendors offer different solutions. If I summarize like a few SDN solutions that we have SDN solution for our enterprise network. We have SDN solution for our data center network. Mainly, if we have the software-defined networking solution from the enterprise network point of view, and we have the SDN solution for our data center network point of view. In fact, in the data center network, we are using this software-defined networking concept for a very long time. Like in the data center environment, the data center network, again, we are not going to go through in detail, but when it comes to a data center network, the design of the data center network is very different than the enterprise network. Typically, a data center is built around certain application that they serve. Data center networks are built around the network, around the application that they serve, that they provide to the customers, that they provide to the branches, headquarters, data center. We say that when it comes to the data center network, the networking that is done, it is more like application centric. So in the data center networks are built around the application that they offer to the clients, offer to the companies and all. So we say that the data center network is basically built around the application that they serve. Data center network is more like an application centric, like data center network is built around the application that they basically serve. So application centric infrastructure is there, actually application centric infrastructure is there in our data center network. We build our data center network around the concept of application centric infrastructure. That's why these data centers are also known as the ACI data center. I'm just talking from a general term point of view. ACI data center means basically like application centric infrastructure data center. ACI data centers are those data centers that are built to serve certain applications, that are built to provide certain application services to the clients, to the headquarters, to the branches, and all those other locations, to the partners, to the other companies and all. We follow a different type of topology when it comes to design. In our data center network, we follow a different type of topology, which is not exactly similar to as our enterprise network. We follow topology such as a spine leaf type of topology, where the traffic goes from north to south, like east west traffic, and different types of concepts are there in the data center network. spine leaf topology is there, different types of traffic are there, end of rack servers, different types of topologies, actually different types of structure can be there in your data center environment. Point is that we use we very heavily use in our data center environment, we very heavily use servers, and in those servers we install some sort of like operating system, such as we can have ESXi, we can have Hyper-V, we can have different types of virtualization softwares running onto those particular server. A data center engineer is responsible to create the VMs, create the resources as per the customer requirement, and basically in short, data center networking is done in a different way than our enterprise network. Basically, that's what I'm saying. Now, the data center network that are built around this concept of ACI, application centric infrastructure, to manage the data center network, like they started using a piece of, again, software, and they called that software as APIC, application policy infrastructure controller. APIC is basically like a centralized controller for our ACI data center. Like we use APIC controller to manage our data center resources. Again, you can install more than one APIC, you can install more than one application policy infrastructure controller to manage your ACI data center, so that you can have HA and all those things. No need to go in details of that. Point is that for the ACI data center, the controller that we have is called APIC, application policy infrastructure controller, and they are using this APIC controller for a very long time. In fact, nowadays we also have this thing called APIC simulator, which you can download from Cisco website. It's around 6-8 GB. You can download it, you can install it in the ESXi environment, and you can have a look how APIC actually works in a data center environment. Again, we don't need to go through that, but APIC controller, application policy infrastructure controller, this APIC controller is being used in the data center environment to manage the data center resources efficiently from one centralized point. It basically made data center network very easy to manage, like from one centralized point, easy to configure from one centralized point and everything. So they thought, like, why don't we use the same kind of concept for our enterprise network? They say that since like this APIC controller is so good that it reduced a lot of administrative overhead, it reduced a lot of overhead from our data center engineers. Now they just need to sit on the centralized controller and they can create all kind of policies and everything. Why don't we use the similar kind of thing for our enterprise network? And they did make, Cisco did make a controller called APIC EM, application policy infrastructure controller enterprise module. They created one solution called APIC EM, application policy infrastructure controller enterprise module. APIC is a different product and APIC EM was a different product. APIC was a different product and APIC EM enterprise module was a different product. APIC EM was built more for the enterprise network, where we don't have that spine leaf topology, where we don't see a lot of servers and everything. APIC EM product that they created, it was more like a solution to manage the enterprise network from one centralized point. Campus LAN switches and those things we can manage from that APIC EM solution that they provided. Other solutions were there as well, but APIC EM, they created an application policy infrastructure controller enterprise module. They created as a controller for our enterprise network. Unfortunately, this APIC EM did not gain a lot of popularity. It did not gain as much popularity as our APIC controller. They no longer sell APIC EM controller in the market. They had other solutions, such as, for example, prime infrastructure. This is this thing called Cisco Prime Infrastructure. This is again one solution that Cisco offers to manage the network, manage the enterprise network from one centralized point. Now, Cisco Prime Infrastructure, Cisco PIE that we have, Cisco Prime Infrastructure. This product is supported by Cisco, but is no longer being sold. So Cisco Prime Infrastructure again was some SDN solution that they, I would say now, used to offer. It is still supported, it went end of sale in 29 September 2023 and end of support is 30th September 2028. So by 2028, you can see anyone who is using prime infrastructure, eventually they will migrate to the other solution offered by Cisco. Still, like, they do have support of it, but actually at the moment it is no longer being sold. This is end of life now. So they had this solution called prime infrastructure, Cisco prime infrastructure. Again, different versions are there that you can, use to basically manage the enterprise network from one centralized point. There were a lot of like options. You can download it, install it in the server, make it reachable, and do a lot of kind of things from this PI prime infrastructure. Later, when SD-WAN became like very for the enterprise network, when it comes to enterprise network, PI prime infrastructure was like the product that they were selling as a solution to manage the enterprise network from one centralized point. Later on, they also had this thing called software defined WAN. When it comes to enterprise network, we have like things such as SD-WAN, software defined wide area network. SD-WAN is also there for the data center network. The internals of the data center networks are managed by the that solution EPIC. But what about providing the reachability to the branches, headquarters, and everything to the data center? In the data center also, like in the data center, this is our data center. Internally, like, things are being managed by that EPIC, application policy infrastructure controller. But what if I need to provide this data center? I need to make this data center reachable via the internet transport, via the MPLS transport to our branches and everything. So here also, like, we have this concept of WAN in our data center environment. And either you can have the traditional WAN or you can have this thing called software defined wide area network. In around 2016, SD-WAN technology is there in the market for a very long time. 2010-12, like at that time, SD-WAN was there in the market, offered by vendors such as like Viptela. Other like vendors were there which were offering SD-WAN solution, software defined WAN solution. They say like the things that we do for our LAN network, why don't you do the same things for your WAN network? Why don't you manage all the WAN edge devices? SD-WAN technology is there to manage all the WAN edge devices from one centralized point. All the WAN edge routers that connect to the internet transport, that connect to the MPLS transport, that allow you to connect to the headquarter, data center, all those. Why don't you manage all those WAN edge devices from one centralized point? That solution is offered by the SD-WAN, software defined wide area network. SD-WAN is like, again, it's not like SD-WAN is only an enterprise network technology. SD-WAN solution can be used by the enterprise network, can also be used by the data center networks. It's all about WAN edge router. Wherever you have the wherever you have the need of connecting your enterprise network or the data center network to the WAN, and using the WAN, like, you are going to connect that to the other branches, headquarters, and all, you can definitely use this SD-WAN technology here. SD-WAN became very popular, like, around 16, 17. Cisco acquired this Viptela. Cisco acquired Viptela. Viptela was a company offering SD-WAN solution. Cisco acquired Viptela around in 2017, somewhere 2017, and then 18, 19, 20, they started selling Cisco SD-WAN solution, Cisco SD-WAN, like Viptela. Like, later on, they renamed it like Catalyst SD-WAN and all. And in 2018-19, it became like very popular product. Like, by the time of lockdown and everything, it was already like very popular product. So SD-WAN technology was there in the market for a very long time, but it like, people started using SD-WAN technology in late 2018, 19, 20, that time. And right at that time, when they saw that, okay, SD-WAN is getting more popularity, why don't we purpose? Why don't we restructure our old SD, like the LAN solution that we had? Why don't we offer some other product instead of using that prime infrastructure? Why don't we offer some other product? What they did actually, they already had this EPIC EM. What they did actually, they used this EPIC EM. They use this EPIC EM actually, and they added some assurance, or I would say monitoring features in that same software, and they launched a new product basically, and that new product is what they were calling as the DNA Center, Digital Network Architecture DNA Center. DNA Center is actually EPIC-EM with assurance feature. Like all the functions that we get in the EPIC-EM, and we were getting in the EPIC-EM, which was not a very popular product, we are now getting all those features in the DNA Center controller, along with some assurance feature. Of course, like they might have modified the codes and everything a little bit, but eventually your DNA Center controller holds all the properties, all the concepts, all the things that we had in our EPIC-EM, plus we have the assurance feature. Assurance basically means monitoring day 2 operations and all those things. And they started selling this thing called DNA Center. DNA Center hardware appliance they started selling, which is what we refer to as SDN solution, software defined networking solution for our campus area network. So if we have a campus area network, if we have a campus local area network, I would say, to manage the campus local area network, campus area network, we have now an SDN solution referred to as the SD-Access. SD-Access basically gives us the capability to manage the enterprise campus area network, enterprise local area network from one centralized point, similar to what we have like SD-WAN, similar to what we have like ACI EPIC, those things. Similar to that, we have nowadays this thing called SD-Access, DNA Center. Basically, all the things that you get in the prime infrastructure, you get in the DNA Center. But again, it's not compatible back and forth. There are tons of new features in the DNA Center, which we will of course explore throughout the content, such as LAN automation. We still can integrate wireless. Basically, everything that you get in the prime infrastructure, you get in the DNA Center. Plus, additional things you get in the DNA Center actually. But the main point is that when it comes to like SDN offering, like Cisco still had prime infrastructure for a very long time, and now they have started that we are not going to sell this prime infrastructure anymore. Instead of that, we are going to use this DNA Center nowadays for the same purpose. Right. There are like tons of differences. Like there are a lot of differences when it comes to like prime infrastructure and the DNA Center.
So is there any documentation regarding those differences? Do we have any?
Okay, let me find that. Basically, like in the prime infrastructure, it was a solution to manage both wired and wireless infrastructure from one centralized point. We can do upgrades, we can do like recovery and all those things. All those features we get here, plus some additional features we get, such as like creating the overlay network based on Lisp and those like VXLAN and everything. Let me find a document if I get. But yeah, like we get almost like all the things here. There is like one document that I found. So Cisco Prime versus DNA Center. So although there are features parity between DNA Center and Prime infrastructure, both are very different devices, have different purposes. DNA Center, like we can manage everything from the DNA Center. Like we can design our network, we can create the policies from one centralized point. We can provision. Provision basically means configuring the devices, creating the underlay network, overlay network, everything, and then we get all the monitoring feature right from. These are four, what we say, 4 tabs that we get in our DNA Center. These are 4 workflow that we get in our DNA Center: design workflow, policy workflow, provision workflow, and assurance workflow. In the design workflow, we can design our network. Policy workflow, we can create the policies. Provision means configuring, and assurance basically means monitoring. We can do all these things. Plus, we get things such as discovering the devices, PNP, get the topology view, platform, and all those things. We can do like a whole sort of things on the DNA Center, which are actually not possible from the prime infrastructure point of view. Right. So right here, I will send you the link in the chat. You can just have a look from there.
Okay. Thanks.
Surinder, Just can you please brief us about Meraki also? What is that product?
Meraki again is completely again Meraki is more like the Meraki SD-WAN basically. So Meraki again is a option that we have. We can manage our switches from the Meraki as well. It's more like a cloud-based solution where we don't have to install any software at our premises and everything. What you can do, you can just purchase, for example, one Meraki supported switch. You can purchase that switch. You can just connect that switch to the internet. You can just execute a few commands onto that switch. The switch will reach out to the Meraki dashboard on the internet. Over the internet to the Meraki dashboard, it will reach out, it will register itself there, and then we will be able to manage all the things from the cloud itself. We don't need to install any controller or anything. It's purely like basically being managed from the cloud Meraki dashboard.
So suppose if I have some switches installed, suppose I have 50 Cisco 9300 installed. Okay. So
they do support Meraki. Yeah, they do support Meraki.
So
we have
all the switches will have to point towards Meraki.
Yes, you have to execute one command. If I have to search that command, but you can execute one command, and once you execute that command, that 9300 series switch, it will reach out to via the internet to the Meraki dashboard. It will register itself on there, and then whatever options are available on the Meraki dashboard on the internet, those things like you can monitor, configure from there itself. Again, not a lot of things will be available, but still like you can still manage those things from there actually.
Okay, so this is not as fast as SD-Access product.
It is not. It does not use a dedicated controller. It doesn't give us. It does not give us that much options as we have in the DNA center, dedicated DNA center, and also for a small businesses point of view, like if you want to manage your network from one central dashboard and you don't want to worry about the centralized controller deployment and everything, then go for the Meraki one. Meraki offers like wireless devices, security appliances, different Meraki based products are there, and that all those products can be managed directly from the Meraki dashboard. No need to install. Like all you have to do is to just do some configuration on those devices, provide those devices with internet reachability. They will register themselves on the dashboard, and then from there you will be able to manage everything. Whatever options are there, you will be able to manage those things from that centralized dashboard. Might not be as efficient as a dedicated DNA center or SD-WAN solution, Viptela based, like the Catalyst SD-WAN solution that Cisco offers for large businesses and all.
So Surinder, with respect to the Meraki, just correct me if I'm wrong. Like Meraki is normally we are using as a out of band solution.
Not only you can say that, but not only like from when it comes to management, we can also push like sort of configurations
to manage all the devices
yeah,
from
kind of yeah, you can say that. But again, it will not give you like as much features as the dedicated SD-WAN solution or dedicated SD-Access solution actually.
Yeah, like because one of the project where I work, so they are using Meraki, and to manage all their routers, switches, firewall.
Can be done.
Dashboard. Yeah,
that can be done. All you have to know like what products are supported by the Meraki. You have to purchase those products. You have to install those products onto your premises. Just register them onto the dashboard, and you can manage those things from there. Yes, correct.
Yeah, but again, say that if your VPN is not working and you are not able to reach to your network, then that was the best solution. You can reach through internet to your
exactly. If you're not able to manage the things like if you have the reachability issues and those things, you can definitely manage from the Meraki. That will be a better solution from that point of view actually.
Yeah, that you can say that like a second option if VPN is not.
Yes.
It's a dedicated like a out of band to manage all.
But again, you have to have supported devices for Meraki.
So for Meraki, Meraki is the Cisco only, correct? So
yes. Okay. But again, like will we be able to manage a 3850 series switch from the Meraki? That you have to see. Will we be able to manage the 9200 series switches from the Meraki? You have to see. You have to see the support, like from the product documentation. You have to see like what products are supported from the Meraki point of view actually.
Compatibility you are telling, correct?
Yes, definitely. Which is also there in the SDA solution as well. Later on, we will see, we will explore that in the SDA also. Like when we want to deploy the software-defined access solution, it's not like you can just purchase any random device and manage it from the DNA center. No, it's not like that. You still have to see the compatibility. So Meraki is more like for the small businesses, like small. If you don't want to deploy like a dedicated controller and everything from the management configuration point of view, then a lot of options you get from the Meraki dashboard directly.
But Meraki, in case of Meraki, the LAN infrastructure will work as a conventional process, not as a VXLAN or Lisp with all these tools.
No, it's like, again, you have to explore the option. Only for the management, more like from the management point of view, that will be there.
Okay. And one more query. For Cisco 9348 or 9400 chassis, okay, if I am using those as a conventional, for a conventional purpose, okay, so if I want to use SD-Access, will I have to put any additional card or anything, any hardware?
No. You just need to upgrade the images to support the SDA, and that will be sufficient.
Okay.
Software and hardware compatibility you have to check, that is sufficient, which we will no doubt discuss later on. But if your 9300 is supported of the SDA solution, no problems, without any additional, cards or any additional module to add.
Thanks.
We will be using 9300 in our labs. Right. So again, just to brief, when it comes to software-defined networking solution, why we were using SDN, why we are talking about the SDN, what is the importance about the software-defined networking? It basically allows us to have the centralized management. We can manage, we can configure, we can provision, we can basically do all sort of things from one centralized point. Software-defined networking solution, SDN, basically allows us to use software to manage our entire network from one centralized point. When it comes to SDN, we have the SDN solution for our enterprise network. We have the SDN solution for our data center network. When it comes to SDN solution for our data center network, we have things such as, for example, ACIE Epic. Epic is the name of the controller that we use in our ACIE data center, like the data center that are built around the applications that they serve. In the ACIE data center, to manage the ACIE data center, we use this Epic solution. Epic solution was so popular that they thought, why don't we use it for our enterprise network? And they did. They created this Epic EM, Application Policy Infrastructure Controller Enterprise module, which actually could not gain a lot of popularity from the enterprise network point of view. Another product that we had for enterprise network management point of view, that was this thing called Prime Infrastructure. Cisco had this thing called Cisco Prime Infrastructure to manage wired and wireless devices from one centralized point, which was a very good option at that time. Then when it comes to the WAN, again, WAN could be anywhere. It's not specific to the enterprise. It's not specific to the data center. We can have the WAN routers in our data center network. We can have WAN routers in our enterprise network, because we want reachability in almost all the cases. We want the reachability to the internet in our enterprise network. We want the reachability to the internet and the branches, the headquarters and all from our data center as well. So when it comes to the WAN solution, we also have the software-defined networking solution for WAN, referred to as the SD-WAN. When it comes to SDN solution, when it comes to SD-WAN, you might have heard that Cisco offers like Meraki-based SD-WAN solution, and Cisco offers like Viptela-based SD-WAN solution, which nowadays is referred to as the Catalyst SD-WAN. In the Meraki-based SD-WAN, what happens, like you purchase a Meraki supported product, and you can just register that product on the Meraki dashboard, and you will be able to do all sort of things from the Meraki dashboard itself. You have to explore the options that you get in the Meraki dashboard, and whatever options are available there, you will be able to use those options. You will be able to do management, maybe a little bit of configurations on the devices from the centralized dashboard. We don't need to install any particular controller. We don't need to download any image. We just need to have Meraki supported device. Just execute a few commands, let that device register on the Meraki cloud, and then we can do all sort of management. Whatever options are available in the Meraki dashboard, that thing we can actually do. That thing we can perform from the Meraki. But when it comes to the Catalyst SD-WAN solution, this Catalyst SD-WAN solution uses this thing called controller. In the Catalyst SD-WAN solution, we have to deploy this thing called manager, which we used to call vManage. Then we have to deploy controller, which we used to call vSmart. Then we have to deploy orchestrator or validator, which we used to call vBond. They have renamed all these things. vManage is nowadays known as manager. vSmart is nowadays known as the controller, and vBond is known as the validator nowadays. V stands for Viptela. So Viptela used to offer like this SD-WAN solution. Cisco acquired Viptela. They now call Cisco SD-WAN Viptela. Later on, they renamed it into the Catalyst SD-WAN. Catalyst SD-WAN, same products, just the different name. So if you want to use like if you have like a lot of branches, headquarters, data center, and you want to manage all the WAN devices from one centralized point, then you can definitely go for this SD-WAN solution. There are plenty of advantages of using Catalyst based SD-WAN over the Meraki based SD-WAN. We get those automated IPsec tunnels from edge to edge. We can manage we can create different types of topology, different policies. A lot of options are there in the Catalyst SD-WAN solution, which of course you will cover whenever you cover the SD-WAN. And again, this thing is not specific to the data center. This thing is not specific to the enterprise network. WAN solution is WAN edge devices are there in the enterprise network, and of course WAN edge devices are there in the data center network as well. But when it comes to the LAN solution, like we have a data center LAN network, we want to manage that LAN network from one centralized point. We have this concept of ACI epic. We want to manage the LAN side of the enterprise network, then either we can use private infrastructure, which will go obsolete more like in 2028, end of sale, end of support. And you should consider using this thing called Catalyst Center, also known as the DNA Center, formerly known as the DNA Center. So DNA Center controller, DNA Center basically again is a centralized controller to manage the campus, local area, campus LAN, campus. Basically, in short, to manage a campus area network from one centralized point, we can go for this SDN solution called SD-Access. And SD-Access uses the concept of DNA Center. SD-Access uses a centralized controller called Catalyst Center to manage everything from the centralized point. Okay. Again, different versions are there for the prime infrastructure. Different versions are there for the SD-WAN. Different versions are there for the Catalyst Center or DNA Center. Different versions are there. With every version, they have improved a lot of things. For example, nowadays our Catalyst Center actually can have our Catalyst Center actually has the capability to get integrated with our identity services engine. We can also integrate our vManage. We can also integrate, we can also create things such as, for example, site-to-site VPN. For example, we can integrate Umbrella. We have like tons of options nowadays in our current version of the Catalyst Center, also known as the DNA Center. With every release, they have always like improved the SDN solution for our campus area network. So the problem was actually in modern day network, in today's network, the majority of problems that we have, it is because of manual configuration. There are many challenges in today's network in managing the network because of like manual configuration and fragmented tool offering. Again, if you want to configure a number of devices, we mostly are going to do those configurations manually on those n number of devices. Also, when it comes to like management of those devices, some companies might use some other solutions for the management purpose. Some companies might use some other tools for the management purpose. There are different tools to do different tasks actually. Fragmented tool offering basically means like there are different tools for different tasks. A company might use more than one tool to manage more than one software to manage the entire LAN and WAN and data center network. Manual operations are slow, okay, because we have to do the changes on all the devices one by one, error prone. While doing the configurations, maybe you did some configurations on the devices and they are proving to be ineffective when in a growing network basically. If your network is growing, then you will notice that these manual configurations are basically not that much effective solution to do the configuration. Again, let's not even talk about the different types of devices that we have in a modern day network. Earlier we used to have workstations. Earlier we used to have only laptops, desktops, printers, servers. These things we used to have in earlier days. Nowadays we have smart devices such as, for example, we have our mobile phones. We can carry our mobile phones everywhere. Every mobile phone has the wireless capability. So not only wired, but we also have nowadays wireless network. Not only like these typical devices such as like laptop, desktop, we also have these IoT devices. Different types of devices are there. Different types of like IoT sensors we can deploy. So with the growth of users and different types of devices coming into the network, configuring user credentials, maintaining a consistent policy across the network for wired and wireless is getting more and more complex. So not only as an enterprise network, not only you have to manage the wired, but you also have to manage the wireless network. Not only you have to manage like traditional devices, but you also have to manage these devices such as like IoT sensors, IoT devices and all. You have to manage the access point, you have to manage the WLC, you have to manage the routers, you have to manage the switches, you have to manage these IoT, different types of devices you have to manage. Users are not static. Users are basically now roaming. Users are roaming from one place to other place. They are carrying their laptop anywhere. They are accessing the network services on their mobile. A user has at least like two devices with them, one laptop, one mobile phone. They can access the network resources from the laptop. They can access the network resources from the mobile device, right? So we have to now create the policy that if the user connects to the network with the help of wired technology, and if the user connects the network with the wireless technology, the same policies must be applied to the user. If the user, for example, belongs to the HR department, the user must not be allowed to communicate with the admin department. This thing has to be enforced for both wired and wireless network. So one policy we will create for our wired network, then we will go to the WLC, and then maybe we will do some configuration changes on there as well. Basically, the rate at which changes are happening, they exceed the human scale. In a growing network, you might see that the very frequent changes, like the changes that are required in your network resources, they might be very frequent. And doing those frequent changes manually one by one, of course, it is going to consume a lot of challenges. In short, basically doing the configurations on the devices, doing the monitoring on the devices, doing like provisioning, software upgrades and everything on the devices one by one is going to be like time consuming process. It is going to be like it will be prone to error, and in a growing network it will not be a very effective solution. And again, that's why they thought of like, why don't we give all these things to a software? Why don't we use a software to manage all these tasks? If I categorize these challenges that we have, if I categorize all these challenges, we can categorize these challenges actually in two places. Like we can categorize these challenges in some challenges that are related to the network operations, and we can categorize these challenges that we have in some security related challenges. We have challenges in operating a network, and then we have the challenges in managing the security for the entire network. Right? So let's say, for example, you have to deploy a new device. Let's say you have to deploy a new switch. Let's say, for example, you have to deploy a new device, and you have to do all sort of configurations on that new device, exactly similar to the previous device. So you will do all the configurations onto that device, and then you will make that device completely up and running in your enterprise network. So deploying a new device, ensuring the policies for those new devices and all, it is again going to be a very challenging task. So there are challenges regarding the operations of the network, and there are challenges regarding enforcing the security for our both wired and wireless network. So networks cannot respond quickly to evolving business needs if the changes needs to be done manually. Some modifications take long time and they are prone to errors. Let's say you had to do the configurations on 10 devices. Let's say you had to do the configurations on 10 devices, and all those configurations needed to be done manually. Then of course it will take more time. Plus, there are very good chances that you might do some mistakes while doing the configuration on one device. and it will affect the overall operations of the network. So to solve all these things, to solve all these challenges that we have, to solve all these problems, like all these challenges that we have this option of using controller. Do not use, like, let's say for example, do not use like do not do all these manual configurations and everything. Use some sort of controller for doing like all those things, right? So variety of challenges are there when it comes to operating the network. Variety of challenges are there in securing the network, and most of these challenges are because we have to do things manually. Maybe like companies are using different like tools to do all those things in an automated way, but again, like different companies might use different tools. A company might use more than one tool. A company might use like more than one tool as well. So that will also be a problematic thing, that you have to manually do all those things. Fine. Now, if you have different types of devices, if we have like different types of devices, how are we supposed to perform like effective segmentation? Here are some devices that are IoT devices. Here are some like our corporate users. Here are some our guest users. What we have to do here, we have to make a policy in such a way, that, for example, these guest users, they do not access our, they do not have any communication with the corporate user, and also, of course, they do not have the access to the IoT devices. How are we going to create a policy? How are we going to first of all do the segmentation between these different types of like devices? Like IoT devices are there, corporate devices are there, guest users are there. They are coming with their own resources and everything. So in short, again, we have to perform effective network segmentation. Segmentation basically means like we have different types of devices. Certain devices should not be able to communicate to each other, but these two, let's say for example, they should communicate to each other. Corporate users, they should have the access to the IoT devices. IoT devices should be accessible to the corporate users, but not to the guest user. So we have to perform the effective network segmentation, which can be exceptionally difficult to achieve in a complex network with a variety of users and devices requiring different access privileges. We can do this segmentation. We can control what devices can communicate with what devices cannot communicate with what devices. We can do that. We can do that with the help of like firewalls. We can do with the help of VLAN. We can do that with the help of ACLs. But all these options, they do not scale well, and they are not very efficient in a real-time environment. Basically, doing the segmentation, controlling what devices can communicate with what devices with the help of like ACLs, VLAN, firewalls, in a real-time environment, in a large network deployment, might not be very efficient way to again achieve the segmentation. In brief, like the point is that networks of today, they do not address the today's business need effectively. Let's not even talk about like how can we reach out to the cloud services, how can we secure our communication with the cloud. We have certain applications that are hosting on the cloud. We have certain infrastructure. We have some SaaS application. We have some infrastructure that we have hosted on the cloud. Let's not even talk about like how can we effectively access the resources that are hosted onto the cloud or infrastructure that is hosted on the cloud. So basically, there are different types of challenges. Again, there are different types of challenges that needs to be addressed in a modern day network. The very first challenge is actually management. we have different types of devices. We have like, let's create a very basic network. Let's say, for example, here we have a few switches. Here we have a few switches. They are all connected in this manner. And let's say, for example, here we have a router. Here we have a router. If you notice, if you remember, if you want to access, if you want to do certain configurations on these devices, you have to manage, you have to configure these devices one by one, unless you are using, of course, some tools. But here what we need to do, if you want to do certain configuration on system number 1, you will first of all take the access of the system number 1, you will do the configuration of system number 1, then you will connect yourself on the system number 2, maybe with the help of telnet, SSH, console, whatever. Then you will do the configuration on system number 2, then system number 3, then 4, then 5, then router 1, then router 2. Basically, you have to do the configuration one by one on all these devices. Then we have APs, then we have WLCs, then we have firewall, then we have other appliances that needs to be managed, and all that management will be done one by one. So doing the management of these devices one by one is going to be time consuming, and it will not be very effective solution in a modern day network, because we have different types of devices that needs different types of like access privileges to communicate with the rest of the devices. So management is basically one. Management related challenges will be there in our modern day network. Security related challenges will be there in a modern day network. We have different types of devices. Certain devices should communicate to each other. Certain devices should not communicate to each other. We can enforce the security with the help of the VLAN. We can enforce the security with the help of things such as, for example, ACL. But in a production environment, configuring ACL with thousands of statements might not be again a very good idea. Configuring a lot of VLANs to perform the segmentation, controlling like what devices can communicate with what devices, again might not be very effective solution. So security related challenges will be there. How are we supposed to separate our corporate user with the guest user? How are we going to enforce the policy that the guest users cannot communicate with the corporate users cannot communicate with the guest user, but corporate users can communicate with the IoT devices can communicate with the corporate. We can do that with the help of the VLAN, we can do that with the help of the ACL, but doing so might not be a very effective way of enforcing security in a production environment. Again, deployment related challenges. We will face a lot of challenges when we have to deploy a particular device. Let's say, for example, we have to set up a new branch. In that new branch, we have to deploy, let's say, for example, 5 switches. We have to deploy like 2 routers, let's say, for example, 2 access point, and we have to deploy 1 wireless LAN controller. When it comes to deployment of the device, again, at the moment, we are considering that everything is Cisco. So we have 5 Cisco switches, we have 5 Cisco router, we have 5 Cisco access point, and we have 1 Cisco wireless LAN controller. When it comes to deployment of these devices, we are going to first of all build a topology based on the same. Then we will do the physical connections. Then we will make the underlying connectivity. Then we will make things reachable. We will make this branch reachable to the other branches and everything with the help of the WAN. Then we will configure some security policy, maybe DMVPN, maybe IPsec, whatever. Again, deploying a new device in a production environment, deploying a new branch, headquarters, data center, whatever you call it, deployment of the device in a production environment again is going to take more time and more resources, I would say. If there was a way by which like this deployment can be done automatically, it will both save our time and of course resources. So deployment related challenges you will also face in your production environment. Let's not even talk about different vendors. Like what about like if we are not even using the same vendor devices? If we are using like different vendor devices, some switches we are using from Cisco, some routers we are using from Cisco, but some devices are from different vendors. Devices, they have different vendors, they might have different ways of accessing the devices, different ways of configuring the devices. You have to go box by box. You have to go on each and every device, take the management access, do the configuration, make it reachable with the other devices, and then things will start working. So of course, deployment related challenges will definitely be there. Remember that every device that you deploy, every router, every switch, every device that you deploy, remember that every device in a traditional network, we follow this concept of distributed architectural planes. Remember that a function of a device can be divided into 3 architectural planes. One is called control plane, one is called data plane, and one is called management plane. Management plane of the device deals with the device management, how the device is being managed. Are we doing telnet? Are we doing SSH? Are we doing like SNMP? How the device is being managed is handled by the management plane of the device. How the data forwarding has to be done, like things such as encapsulation, decapsulation is done by the data plane of the device. Data plane is the part of the device that is responsible to perform things such as decapsulation, encapsulation, like those things, like actual data forwarding is done by the data plane of the device. And who tells the data plane how to forward the data? Control plane. Control plane is basically responsible to build different types of tables, such as routing tables, such as ARP cache, that will be looked up, that will be checked to decide like how the data has to be forwarded. Basically, from the architectural point of view, functions of the device can be divided into 3 architectural planes called control plane, data plane, and management plane. And every device has its own set of control plane, management plane, and data plane. That's the point. If I have 3 switches, this switch will have its own control plane, management plane, and data plane. This switch has its own control plane, management plane, data plane, and this switch has its own control plane, management plane, and data plane. That means if I have to manage this switch, then I will connect to the management plane of this switch. I will connect to the management plane of this switch. Then I will connect to the management plane of this switch. I will telnet, then telnet, then telnet. I will connect maybe console, then console. One by one, since the management plane is distributed, since the management plane is on box, since every device has its own set of management plane, that's why we need to access this device one by one to do all the configuration.
So Surendra, here, these 3 switches you are talking independent. There are 3
different, yeah. No stacking, no nothing, no extra technologies.
So in case if they are stacking, then there will be a single management plane.
Yes, exactly. But you have to do some stacking configurations and everything. Yeah. You will require some additional concepts in that case.
Yeah.
Point remains the same, that if you have a 2-tier or 3-tier architecture from the design point of view, and you have not used any additional technology such as stacking or VSS, you need to connect to these switches one by one for the management purpose. Why? Because everyone has its own set of management plane. Why do we need to configure OSPF on all the devices? Why? Because this router, this device is responsible to build its own table, such as, for example, routing table, such as, for example, ARP cache. When the packet arrives on this device will use its own routing table, its own ARP cache to decide how the data has to be forwarded. So whatever information I have on this device can only be used by this device, not by this device, not by this device. It is only when we configure a protocol such as OSPF between them, it is only when these routers, they exchange the route information, then all of these devices, they have the same routes in the routing table, and then they will be able to forward the data. Why don't we just configure OSPF on one device and that is sufficient? Why? Because everyone has its own set of control plane. Everyone needs its own set of routing table. Everyone needs its own set of ARP cache, spanning tree database, and all those things. Every device maintains its own set of tables, and it will use those tables to basically decide how the packet has to be forwarded. Every device has its own set of, I would say, control plane. There is no centralized control plane. There is no centralized routing table that can be referred by all the devices to decide how to forward the data. Every device has its own set of data plane. Distributed architecture we are following. Everyone has its own set of control plane. Everyone has its own set of data plane. Everyone has its own set of management plane. Since everyone has its own set of architectural planes, it's more like a distributed architecture. That's why we need to configure each and every device manually. That's why we have to configure protocols such as OSPF, EIGRP on each and every device manually, so that every device can decide how to forward the data from one port to other port. It's not a challenge, but it because of this distributed architecture, actually we are required to do all the configurations on all the devices again and again. Yes.
You are talking about something about multi-vendor environment. How can SD-Access help us in multi-vendor environment?
It can't. It can't. It is specifically the SDA solution that we will talk about as a part of our content. It is specifically for Cisco. Devices that support things such as, for example, SNMP can still be managed by the DNA center, but you will not get full-fledged functions of the SDA, offered by Cisco. Even the traditional devices that we have that can respond to those SNMP messages, where we have the support of SNMP, they can be managed, but you will not be able to get the full-fledged functions of the VXLAN and those things. You will not get those support in a multi-vendor environment. Definitely not.
Thank you.
Right. It's not a challenge in front of you. The thing that you see, it's not more a challenge, but it's why basically, like, since we have distributed control plane, management plane, and data plane, it is why we have to do the management on all the device one by one. The routing protocol we have to configure on all the devices so that they form the routing protocol adjacency, they exchange the routes, they build the database, and then they decide how to forward the data. What about then someone reports? You have like 150 branches, headquarter data center all together, and someone in the branch number 75 is reporting that in our branch, actually the admin department, they are not able to access certain resources of our data center. Someone is reporting that, okay, we are not able to access the resources of the data center. Now you will need to do the T-shoot. And when it comes to T-shoot, you will do that T-shoot manually as well. Basically, once you made your network up and running, once you made your network operational, after that, some challenges will arrive as well, such as some operational challenges will arrive as well. Such as, for example, someone is reporting that in our branch, we are not able to access the network resources of the data center. We were able to access it last day, but today when we came to the office, we are not able to access the resources of the data center. And then you need to check why those users are not able to access the resources of the data center. You will need to log into the devices of that particular branch to check any possible logs and everything. Of course, you might have some monitoring softwares. From there, you can do all that management and everything. But again, you have to check those logs. You have to check those devices to find any potential problem that might have caused the unreachability between the devices. What if Cisco has launched the new software and you want to now upgrade all the softwares onto those devices? Like, you have hundreds of devices, and on all those hundreds of devices, you want to upgrade the software. So you will download the software, then you will put that software in the pen drive, then you will connect it onto the device, and then do the upgrade one by one. All the devices, again, might take a lot of time. What I'm trying to say is that once your network is completely up and operational, still after management, still after that, operational related challenges will still be there. Not only we have wired network, we also have a wireless network. How are we supposed to create a policy for both wired and wireless network in such a way that a particular user, no matter if it connects via wired or wireless technology, it doesn't matter, it will never get to communicate with the guest users. We have to configure a separate policy for wired user. We have to configure a separate policy for our wireless user. Having separate policies for our wired and wireless user is also going to impose a few challenges. If we had a concept of like unified policy that can be applied for both wired and wireless user, it will be good. It would be like much better option. What about the devices that we have on the cloud? What about the cloud hosted in softwares? What about the cloud hosted infrastructure? What about nowadays everyone is talking about automation? What about like we have some some people, they are very good in like scripting. They know a lot of like languages such as like Python and all, and they can create a good script. And what we want, like when I run that script, once that script runs, OSPF will get configured on multiple devices at the same time. But if like we want to have that kind of function, that kind of support in our network as well. How can we improve the user experience, like when it comes to connecting to those cloud delivered services, such as like cloud delivered software, cloud delivered infrastructure? Like again, what about the IoT device? A lot of challenges in a modern network. You will see that a lot of challenges are there. A lot of, since the technology is evolving, different challenges you might face in operational challenges, configuration challenges, deployment challenges, security challenges, different challenges you will face in your modern day, in your current network. In fact, they say, this is one old chart. In fact, they say that 95% of network changes are done manually. This is as per Cisco. They did some R&D, and they are saying that even till death, they have like 95% changes, 95% network changes are performed manually. 75% of operational expenses spent on change and troubleshooting. They say that 70% of the policy violation occurs due to human errors. They say that the ratio of the operational expense to the capital expense of the network operations, labor and tools is basic. Like we are spending more money in operating the network than the like overall capital expenses. Basically, as the technology has evolved, as new things have come into the market, it is basically hard to manage all those devices, all those things from like manual configuration point of view. And that is why because of these variety of challenges that we face in network operation, the variety of challenges that we face in our security, that is why they decided, why don't we use like some softwares, why don't we use some software defined approach to manage the things. In the software defined networking, what happens, like we will define our intent. We will define what we actually want to achieve. We will define our intent. We will define, for example, that we want HR department should not be able to communicate with the finance department. We will define our intent. We will go to the GUI, and here we will define our intent, what we actually want to achieve, and this piece of software will automatically configure the devices in such a way that your intent, like as per your intent, basically the piece of software is going to configure your network in that way. Intent based, we call it intent based networking. We call this thing called intent based networking. To have this intent based networking, where the engineer define their intent and the software basically configures that intent in the network. They did create these softwares. They did create these softwares which are responsible to manage the enterprise network, manage the data center network, manage the WAN, manage the LAN, and they created like there are three different SDN solutions and programmability options available from Cisco. Others are there as well, but there are three main of them. One is called Open Daylight Controller. It is like Cisco Open SDN Controller. This was solution offered by Cisco very initially. Cisco Open SDN Controller. This was a solution that they were selling. It was based on this Open Daylight concept, which was like more like an open standard solution for software defined networking. They don't use it anymore. It has gone completely obsolete. Then they have Cisco ACI, application centric infrastructure for the data center network, where they use the controller named Epic. Then they had Epic EM for enterprise network. They had other products as well, others such as, for example, you said Prime Infrastructure, for example. Prime Infrastructure was a very popular solution. It is still in the network, but again, Cisco no longer is selling this solution, so it will go obsolete sooner or later. Point is that other solutions are there as well, such as, for example, Prime Infrastructure is still being used in some of the production environment. They did create, these were like some old solutions. They did create these variety of solutions when it comes to like software defined networking. But when it comes to the modern day network, we have three options in total. We have SD-WAN, Cisco SD-WAN for next gen wide area network. Then we have Cisco SD-Access for the campus area network, and we have EPIC for the data center network that is based on application-centric infrastructure. Again, these are Cisco's offering. Like, we are not talking about other vendors. These are like Cisco's offering when it comes to software-defined networking. These are like Cisco's. There are things other than these ones as well, such as we are still using prime infrastructure. We are still using like Meraki based SD-WAN. We are still using traditional APWLC approach to manage the access point from one centralized point with the LAN controller. So there are other solutions as well, but when it comes to software-defined networking, three major solutions that Cisco offers basically is Cisco SD-WAN, known as nowadays Catalyst SD-WAN, Cisco SD-Access, and Cisco EPIC Application Policy Infrastructure Controller. So if you want to have the end-to-end, if you want to have a complete like SDN solution, if you want to have like end-to-end SDN solution, you have to go through at least these three things. In your data center network, you are going to configure EPIC ACI EPIC. For your WAN, you will have the SD-WAN solution, and for the campus LAN, you will have the SD-Access solution. Then you will have end-to-end SDN solution for your production environment. End-to-end SDN solution basically means, like in our branches, we have software-defined branches. For our data center, we have software-defined data center, and for our WAN, we have software-defined wide area network. It looks something like this. This is like end-to-end SDN solution, again offered by Cisco. Other vendors might have similar things like that, but since we are talking about Cisco, this is end-to-end solution offered by Cisco. This ACI data center is being managed by the controller called EPIC, Application Policy Infrastructure Controller. The engineer is responsible to define the intent on this application. You know that, let's not go in detail, but endpoint EPG, endpoint groups we have, then we can configure the policies for endpoint groups and everything. Engineers are supposed to define their intent on this application policy infrastructure controller, and then they can manage the ACI data center from there. When it comes to the enterprise network, to manage both LAN and to manage both wired and wireless devices, these are some wireless access points which we want to manage. We have a wireless LAN controller here somewhere. This WLC is responsible to manage all these wireless devices. And if you want to manage these LAN switches from a centralized network as well, then you can go for this SDA solution. In fact, SDA solution is not only for wired, but it is also for the wireless network. So in a campus area network, we can go for SDA solution based on this controller called DNA Center, or known as the Catalyst Center nowadays. Catalyst Center or DNA Center is a centralized controller to manage the campus area network, both wired and wireless. We can manage both wired and wireless. And when we want to connect both of them, this is our campus area network, and we want to connect this campus area network with our data center network, and we want to have that connection done securely from one point to other point, then definitely we can go for the SD-WAN solution. Instead of using traditional router, instead of configuring IPsec tunnels, DMVPN, all those things manually, we can go for SDN, we can go for software-defined networking. Instead of configuring our traditional WAN network, we can purchase and install the router that can be managed from one centralized point, and we can have this SD-WAN, software-defined wide area network. So these are SD-WAN routers. These are software-defined SD-WAN routers basically. These are SD-WAN routers, and these SD-WAN routers are managed by the centralized solution offered by, again, Cisco Catalyst SD-WAN.
So Surinder, one question here, like when you're telling these routers are SD-WAN, so what these are especially designed SD-WAN router or any ISR router you're talking about, like 4303s or 4200 series or
No,
1000?
yeah. So we have specific routers for SD-WAN, such as running on Viptela operating system. But since Cisco is forcing things, or Cisco is basically telling everyone to use iOS XE, these are those routers which have the capability, which are running on iOS XE SD-WAN. This could
So
be this could be normal routers as well, like
okay, so
ISR 4000,
suppose
1000 series routers.
I'm not running SD-WAN in my environment, and
Huh,
I have a ISR router 4300 series.
huh,
It
huh,
can it be converted to SD-WAN router? Is
huh,
that
huh,
possible?
huh, huh, fine. You can just download, you can just go to that product specification, like for ISR 4300, for example, you are using, just see, look for this image, iOS XE SD-WAN,
Okay.
right? You have iOS, so you have iOS XE and you have iOS XE SD-WAN. So if you, nowadays there is only one image nowadays, from the release of the iOS XE version 17.2, if I'm not wrong, from this release there is just one image that you can download on the devices, and you can use this either either you can use it as a traditional router, or just use one command and convert this router into the SD-WAN router. Just one command.
But for that, I believe we need to take license for SD-WAN, correct?
Yes, then of course you need to purchase the SD-WAN solution, you need to deploy the controllers somewhere, you need to make them reachable, you need to purchase the SD-WAN licenses and everything. The SD-WAN license comes with the name of DNA license actually. So yeah, of course, definitely.
Thank you, Sandra.
But the whole point is basically, if you want it, you can have end-to-end SDN solution from your LAN all the way to the data center. DNA question is DNA spaces something included in the DNA center? We can, DNA center, DNAC is basically a controller that we install in our production environment. We make that controller reachable to all the devices. DNA center can manage all the devices from centralized point. DNA center can pull the statistics, different types of assurance related information from all the devices. And we can integrate DNA center with DNA spaces. DNA spaces is something different actually. We can integrate the DNA center with the DNA spaces, so that we can manage our DNA center from that DNA spaces, that website that Cisco basically has. So it's more like an integration thing. So yes, DNA spaces is something different. It's more like a solution to manage manage the DNA center from one cloud-based portal, something like that. You will not be able to do a lot of things from the, we have to perform the integration of the DNA spaces and the DNA center, and then you will be able to manage the things from the DNA spaces actually. You have to see the support of it. You have to see the support of on your DNA center. Do you have the support of that or not? I believe this integration is supported after a specific release. So if you have that specific release of the DNA center running, then you can integrate that DNA center with the DNA spaces, and you can manage your DNA center solution from the DNA spaces. So that is more like a different thing actually. It's like if you have gone through the SD-WAN solution, there is this thing called V analytics. I'm not sure if you have gone through it or not, but there is this thing called V analytics. V analytics is a cloud delivered analytics engine, that allows you to monitor the SD-WAN solution from the cloud itself, monitor the network insights and everything in much more better way. It pulls the data from the vManage and it shows you in a centralized cloud-based dashboard, and you can manage the things, you can monitor the things from there. Kind of that similar thing that we have there, DNA spaces. I guess.
Yeah, Surinder, Lakshman here. Like DNA spaces is more over about operation conditions, kind of an environment, right? How environments looks like, about the humidity and about the
More like
temperature.
monitoring like more like. We can monitor our
Right,
DNS
like
solution from
earlier,
the spaces.
right, because like earlier we do have kind of a CMX kind of solutions where
Hmm.
that
Hmm.
was part of this DNS spaces now, right?
Yes,
So
yes, 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 yes. But proper, I believe like proper integration has to be done from the DNS center to the spaces. Then you will be able to do some management from the DNS spaces itself. Actually, it is more like cloud delivered service that you get, and you can do certain management like from the DNS spaces as well.
Hi, Surinder. Like
Yeah,
last question from my side.
yeah,
So
yeah.
I'm just checking from DNA perspective, but
Hmm.
correct me if I am wrong. Okay,
Hmm.
like from security perspective, when we upgrade the FTD, okay, from FMC, okay,
Hmm.
so like if we are upgrading our FMC, so the FTD will traffic will not reflect, correct? That is because FMC is the like management traffic,
Management, huh?
and same
Hmm.
if I'm talking about from Palo Alto, if I am upgrading the Panorama,
Hmm.
the other firewall will not reflect, correct?
Okay.
So in case of if I'm running a DNA in my environment, and if I
Huh?
upgrade my DNA, whether my data plane traffic will affect or not.
No, 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 no.
So there,
Data plane traffic does not go via the DNS center. Yeah.
okay, so there is no any like it is, so how they are replicate means if I want to upgrade my DNA center from
Huh?
this version to that version,
Huh?
whatever
Huh?
you are telling 2.3 to
Huh?
2.7,
Huh? Huh?
so in that case how you are telling that traffic will not
Traffic, because the traffic, when it comes to traffic forwarding, the DNS center is more like the management plane. The control plane, data plane concept is actually still on the devices. So devices, they build this thing called VXLAN tunnels and everything. Once we have set the roles on the devices, once from the DNS center we have set the roles on the devices, those devices will keep operating based on the configurations that are pushed from the DNS center to those devices. So even if the DNS center gets disconnected, your data plane will keep operating. However, the DNS center will not be able to collect the statistics and those things for that period of time. But since the information is already present in the branch switches, the control plane, management plane, data plane is already there. We have a centralized control plane in our DNS center deployment. We have SDA deployment. We have a centralized control plane. We have set the edge roles and everything. So based on that, actually, you can say data plane will not be impacted. Only for that time period when the DNS center is basically getting upgraded and everything. The management, you will not be able to do the management from the centralized point and all, but data plane will not be impacted because they will already form the tunnels and everything. It will not affect any data plane traffic.
Okay, so in that case, when we upgrade like any other firewall or FMC or Panorama, we restart the device. So if I upgrade the DNS center, whether it's
Uh-huh.
required a restart?
Yes, DNS center will automatically reboot once it starts,
Okay,
and then it will start all the services and everything. Yes, yes, that's correct.
okay. So during that window of time, whatever the change window I took
Hmm.
and
Hmm.
upgrade the DNS center, the
Hmm.
any change in the production will not reflect. Is I'm right?
Yes, you will. Yeah, then you can, if you have done the changes on the devices manually during that time, right? Let's
Yeah.
say you can resync it. You can go on the DNS center. We have the option of resync. By default,
Okay.
DNS center resyncs the configuration in every 24 hours. You
Okay.
can resync right away, and it will pull the information from the devices and it will show you on the DNS center.
So 24 hours you are telling it is designed automatically or you have to
Yes,
define it?
no, that is automatically. If you want to do the resync, you can resync it right away.
Okay. Okay.
Otherwise, it
Thank you.
will resync the configuration of the devices at a certain time period.
Yeah. Yeah. I'm trying to understand. DNA is very new to me, so I'm just trying
No, no,
how
no
it is
should,
similar with my
no
other
should,
other
no should.
devices.
So the point is that DNS center is just more like from the management configuration point of view. You can still do the configuration from on the switches from like manually as well. But
Okay.
the point remains the same. If you do the configuration changes manually on the switches and you want those changes to reflect on the DNS center, you can
Okay.
resync. There is an option like of called resync. Like let me show you quickly.
Through provision you're telling, correct?
Provision
No, no,
is
from an inventory, I believe. Means
so you can just go to the inventory and you can just select a particular device where you
yeah,
might
yeah,
have
yeah.
done some certain changes, and you can just select that device and you can just resync. Just do that resync option, like action and inventory, and then here resync.
Okay. Okay. Got it. Got it.
Right. So it will basically resync the configuration of the devices, and it will show you. Then you can check the configuration on there. And I believe if I go here, I'm not sure if we do have it does show you like the resync interval. I'm not sure if they have. We will see in our DNA center later on, but it shows that what is the default resync interval actually.
Okay.
So
Thank you.
we can do that, but again the data plane will not be impacted. The point remains the same.
Okay. Thank you so much. Thank you.
So again, just to brief, we can go for end-to-end SDN solution. If you want to go for like end-to-end SDN solution, you can go for the end-to-end SDN solution by combining three things. We have the SD-Access solution for the campus area network. We have the SD-WAN solution for the WAN edge devices, and we have the Epic EM for the ACI data center. So the traffic all the way from the end user, the traffic will be received by this edge switch. Edge switch is going to either let's not go in detail at the moment, but the edge switch can encapsulate the traffic using some protocols such as, for example, VXLAN. It will send it towards the other switches. It will send it towards the other switches, and from there it can reach out to the other devices. Similar to that, if this user has to reach out to someone, let's say for example here in the data center, then it can send all the traffic to the edge router. Edge router internally, it will perform encapsulation based on technology such as VXLAN. Edge router, when it forwards the traffic towards the other edge router, it can securely forward the traffic with the help of like IPsec, because that's how SD-WAN works. SD-WAN automatically forms IPsec tunnels. Traffic will get encapsulated via IPsec, will be received down here, and from there internally, however you have made the routing done, traffic will go to the data center. So the end-to-end solution, complete end-to-end solution you can go for with the help of these three things. If you want to go for the end-to-end solution, you have to go for like these three things: as the WAN for WAN, as the access for the LAN, and just in case if you are using like DNA center, then you have to just in case if you are using the data center, then you have to go for ACI and Epic.
So I have one question. How this SD-Access will be integrated with the SD-WAN Viptela?
We do have the option, like they are trying actually. Cisco, they are trying to make the DNA center centralized controller for, like I would say, everything, but still the functionality is very limited. Let me show you quickly. So okay. We do have in the DNA center, we do have the option. In the DNA center, we do have the option. If I go to the DNA center dashboard, I can go here. I can go to the, where is that option, system. I can go to the settings, and on here I do have the option to integrate external services. You see right here, we can integrate like external services. We can integrate our right here vManage.
vManage, okay.
Right. So
from here we can give the IP of the vManager.
IP, username, password, and those things. So it's more like the DNA center will give the instruction to the vManage, and vManage will pass it to the other edge devices, right? Like that.
Okay.
We can also integrate other solutions, such as, for example, we can integrate other solutions such as, for example, Umbrella. We can integrate solutions such as
all the LAN routes which are coming from this SD-Access will get advertised to the like remote branch. If, for example,
that will be completely dependent on that will completely be dependent on the configuration. Like how we have configured it. It will be dependent on that actually. But the SDA routes can get advertised to the traditional network. Traditional routes can get advertised to the SDA network. That is fine.
Okay, so the LAN routes can be
made reachable. Okay. We will do that as a part of our content. We will practically do that. We will have some traditional network. We will have some SDA network, and we will see a ping, and we will do the ping from the SDA to the traditional to the SDA.
Okay.
In fact, we will have our DHCP services running on a centralized data center, and then we will try to get the IP of our SDA end user from that centralized DHCP server.
Okay.
Right.
Okay. Thank you.
Here is your, where is that? Here, right here, here is your DNA spaces. Right. So we do have option like 1000i is also one thing that is like, they are focusing a lot on 1000i. So 1000i can also be integrated on here. A lot of external services can be integrated under this DNA center solution.
Surender, I have a question. Like, is it only, I mean, like, we'll be able to integrate only with Viptela SD-WAN, or even we can
Yes,
integrate,
yes,
kind of
yes.
integrate?
Yes. Unfortunately, Viptela SD-WAN, yes.
Okay, okay.
Because in Viptela SD-WAN we do have the dedicated protocol called OMP, Overlay Management Protocol, which is not compatible with the others. So anyway, like this solution can only be integrated with the Cisco SD-WAN solution.
Understood, understood.
Sridhar?
Yeah.
We deployed this DNA center in data centers, and we have branch 1 and branch 2. So through branch 1 and branch 2 data center, we have only internet site-to-site connectivity.
Okay.
So in these situations, can we manage the branch 1, branch 2 devices through DNA
as
center?
long, see, the only thing that matters actually is the reachability. If the DNA center is able to reach to those devices that you want to manage, it will be able to do the management. It will be able to push all the configuration to form necessary overlay tunnels and everything. So if you have the reachability from the branch 1 and branch 2 to the DNA center that is hosted on the data center, definitely you will be able to manage it. In fact, this is what we do. Like we deploy our controllers such as vManage, vSmart, vBond, DNS Center, WLC. We do all that deployment in the data center. We make it IP reachable from the branch point of view, and the branches will be able to now they will be able to be managed from the DNS Center, WLC, or vManage, vSmart, and those things. So yeah, fine. As long as reachability is there, it's all good.
Those the devices which are in the campus, do we have to install some license like we do in
Yes,
SD-WAN?
yes.
In
We
order
will
to
require license. We will talk about license here.
So once it has been managed by DNA Center, so the policy will get, means that configuration will be pushed from the DNA Center, correct? So
From the
once
DNS
it
Center,
is,
yes.
yeah. So can we do the configuration changes through CLI?
You can do that, and you can just resync it. It's not like we, just in case if you are comparing it with the SD-WAN solution, it's not like SD-WAN.
Okay.
Like
So it's
in the SD-WAN, what happens if the router is being vManaged? That means the configuration changes can only be done via the vManage, right? That is not like that here. We can still do the changes on the local switch itself, and then we can resync that thing. We can resync those changes on the DNS center. We can do that, and not unlike of course unlike the SD-WAN solution.
So for every devices we have to have we will have a separate policy or configuration, you want to say?
If you want that kind of thing, then you have to go on each and every device, then you have to configure it. That will defeat the purpose of the software defined networking. But again, if you want to do one by one, then you can still do it one by one. Otherwise, you can just go here, policy, and do whatever you want to do from here.
Because why I'm saying, if you are saying that we can do the changes in the CLI, so it will be means so if suppose I've done some changes on regard ACL, okay, in other devices the ACL will be different.
Okay. Issues will be
So
there.
yeah, so the configuration will be different, no?
Of course. Then that's the point. That's
So
the
for
manual
that
issues.
so for that particular device, a separate policy will be created in the DNAC.
No. DNS center is
Because
more
we have
like
to,
going
once
to
something is done.
no. DNS center will more like resync the information of that device. Like for example, once the time whatever it is, like 24 hours, for example, once it is done, it will resync the configuration on the DNS center, and then based on whatever configurations you have configured, whatever configuration you have done on that particular device, based on that only it will do all the forwarding and everything. DNS center has no role in data forwarding. If you have done something from the device on the device itself and you resync it, there are chances like whatever configurations you have done here, they will get pushed onto the particular device.
Okay. So practically only we can understand,
No,
because once we
practically you
see.
don't. Whatever you want to do, whatever you want to do, for example, when it comes to like policy application and everything, try to do it from this box itself. Later on, when we do the configuration, we will see practically, like if I do the configuration changes we will do that. We will do the configuration changes on the interface manually, and let's see what happens like when we resync the configuration on the device. We will see that.
Okay. Yeah. Thanks.
So, Surendra, can we say that this DNA Central and vManage are like similar? I mean,
DNA Center and
uh,
vManage are similar. Yes, yes, very much with a few
very much similar.
differences. Like, but
Because in
again,
vManage also we
just
manage the
hmm,
devices, and
huh,
control plane is with
different or
vSmart
different
and
place. Ha, ha, ha.
yeah.
So like vManage is the centralized NMS for SD-WAN solution. At the moment, right now, at the moment, you can say that our DNA Center is a centralized management station for our SDA, like for our software campus area network.
Yeah.
But again, we get a lot more options. We get options in the vManage as well. We get options in the, of course, here as well. We can do all sort of configurations, provisioning, monitoring, and everything on here as well, there as well. So quite similar, but here and there a few things will be different, such as like one point that that was that was put that in the vManage, like when the device goes in the vManage mode, then the changes will only be done from the vManage. Here,
vManage,
that's not
yes.
the case.
Oh, okay. So
Right. So
here we
here and there
can
a few
still
changes are there.
manually.
Here and there a few changes are there, but the rest are okay. Rest are like exactly the same.
Okay. So here manually changes are allowed, even if the.
But what will be the effect of those? We will do it practically, and then we will find out.
Okay.
Right. So we can go for like end-to-end SDN solution using these three again products offered by Cisco. One we have SD-Access, one we have like ACI Epic, and then one we have the SD-WAN. Right. So basics we have covered. Now we will talk about it specifically. We'll talk about our SDA solution and how the SDA solution is going to help in managing our campus area network. So this was just the basic introduction of the software-defined networking, why we need it, what are the challenges and everything. And I guess that is it for today. Tomorrow we'll talk about our SDA solution. Nothing that we have covered today like in very detail. Tomorrow we'll talk about like what is SDA, what components we require in the software-defined access, how to, what compatibility and everything we will talk about tomorrow. So chapter number 1 from your official book. Now you can go through. So when it comes to like Cisco SDA is basically something that is offered by Cisco DNA, Cisco Digital Network Architecture, or Cisco DNA. So DNA Center basically, again, like we covered in the last class, what is software-defined networking? In a software-defined networking, we have a piece of software that is responsible to manage like the entire network, and that software will be installed on maybe some hardware. This hardware could be sold by Cisco or some other vendor. Like for example, we can install these SDN solutions in a virtualized environment such as ESXi, like Hyper-V. Maybe nowadays we can also do it on the cloud and all. So like we have a piece of software, we have a software that has to be installed somewhere. Let's say, for example, we are installing that software on a particular hardware. This hardware could be like, Cisco UCS, or it could be like some simple like server where we are running like ESXi and everything. So that piece of hardware, or that place where we have installed that particular software will be responsible to manage all the like network resources, all the like entire network will be managed from there. That is what we will be referring to as the controller. So controller is something that is responsible to manage the entire like network from one centralized point. And different SDN offerings, different SDN solutions, they offer different controllers. Such as, for example, when we talk about SD-WAN solution, in the SD-WAN solution, we have the controllers called vSmart, vManage, and vBond. They have been renamed. So now vSmart is nowadays called controller, vManage is called manager, and vBond is called like validator. So, but again, like in the SD, when it comes to SD-WAN, we have the controllers named as vSmart, vBond, and vManage. When it comes to like data center, we have that EPIC, application policy infrastructure controller. And when it comes to the software-defined access, which is our course focus, in case of software-defined access, the controller that we talk about is called DNA Center, Digital Network Architecture, DNA and Center, which actually has been renamed again to Catalyst Center. So nowadays we call that Catalyst Center. So Cisco SDA solution within Cisco DNA Center is built on intent-based networking principles, where like the network engineer will define its intent onto the controller, and it will be the responsibility of the controller to push that intent onto the networking devices. Such as the network engineer will say that I don't want these two devices to communicate to each other. I want these two devices to communicate to each other. The network engineer will define its intent onto the controller, and it will be the responsibility of the controller to push that intent onto the devices. Do all the necessary configurations on the devices so that like the desired communication is allowed or blocked accordingly. So to meet the intent of the network engineer, whatever configurations are needed, those configurations will be pushed by the DNA center, by that catalyst center to those devices. So Cisco SDA, Cisco Software Defined Access, is a solution within the DNA center. So the product name is DNA center. Product is basically DNA center or the catalyst center. And DNA center, catalyst center offers like a lot of things. Not only like this Cisco SDA. Already we have seen the user interface of the DNA center. Let me show you one more time. So this DNA center, this controller that we have, this controller basically offers Cisco SDA, Cisco Software Defined Access, is actually one of the solution that this controller actually offers. Let me show you. So this is how the graphical user interface of the DNA center looks like. We'll see like from where you are going to get it today. So this is how the DNA center graphical user interface looks like. This is the once you make that DNA center up and running, this is how the graphical user interface, this is how the GUI of that Cisco DNA center looks like. And then if you go to this these three here, you click on that, you can see that in the Cisco DNA center we have 4 major workflows. These are called workflows. We have design workflow, we have policy workflow, we have provision workflow, and then we have the assurance workflow. Then we have like some other platform tools and those things, but majorly we have design, policy, provision, and assurance. These are 4 major workflows that we have within the scope of within this DNA center or catalyst center appliance. So if you go to the provision workflow, under the provision workflow, we get this SD-Access. Under the provision workflow, we get the option to build our fabric. We build our overlay tunnels. We build our like VNs and everything. Basically, everything regarding the SD-Access is under the provision and SD-Access. So if you want to build a campus fabric around the SD-Access technology, you will get that under provision. You will get that under SD-Access. Apart from that, apart from this SD-Access capabilities, it has like a lot of other things as well, such as, for example, we can create the policies right from here. We can design our entire network from here. We can do all kind of monitoring from here. Then we have for example, we have different tools. Using these tools, we can discover the entire topology from one centralized point. We can run variety of commands. For developers, this is platform workflow. So if you are good with development, if you are good with like programming languages and everything, you can go to the developer toolkit, and here you can explore variety of like API options. So you can build the build a code, you can build a program, you can build a an API call, and using that API call, you can do variety of things with the help of the API as well. Not if you don't want to do via GUI, you can do it with the help of the API and all. So again, SD-Access is just this one. Go to the provision, SD-Access, and SD-Access is just this one. This is the SD-Access. Apart from this SD-Access capabilities, we have other options as well, which we will explore throughout our content. But the point is that Cisco SD-Access, Cisco's software defined access, is a solution within the DNA center architecture. So here is the DNA center, here is the catalyst center, and within the catalyst center, we have an option called SD-Access, which is to build our campus fabric with the help of the software defined networking concept. So Cisco SDA is a solution within the DNA center, which is built based on the intent-based networking model. Intent-based networking basically means where the network engineer will define its intent on the controller, and it will be the responsibility of the controller to push all the configurations on the devices to meet that intent.
Surendra sir?
Yes.
Sir, this DNA center, does it work on HTTPS or we have some other platform to access?
We will see. Like if you want to access it, you can access it with the help of the HTTPS basically. But other options are there as well, such as it supports programmability. So APIs and those concepts are also there. When it comes to discovering the devices, it uses like SNMP, netconf, those things.
No, means I'm specifically asking for this DNA center.
HTTPS. You have to, if you want to take the GUI access of it, then HTTPS based access, HTTPS based access you will take.
Okay. Thank you, sir.
Right. So again, what things we get from the SDA solution? We get like visibility based automated end-to-end segmentation. Cisco like SD-Access solution provides visibility based automated end-to-end segmentation to separate the user, devices, application, traffic without redesigning the underlying physical infrastructure. So this basically says that you can have whatever type of infrastructure you have in the in your network. This is the type of infrastructure that we have. Let's say, for example, we have the access layer, we have the distribution layer, we have the core layer, then we have the edge and everything. It says that you can have whatever type of infrastructure you have. You can have whatever type of infrastructure. You can have whatever type of underlying infrastructure. Doesn't matter. You can use any protocol, like for example, EIGRP, you can use OSPF, you can use any protocol to make these devices reachable. As long as these devices are reachable with our centralized controller called DNA Center, Catalyst Center, as long as the DNA Center, as long as the Catalyst Center can reach to these devices, we will be able to move our traffic from one of the device to other device without redesigning our underlying infrastructure. So we can say that this underlying infrastructure that you have created, this underlying reachability and everything that you have created, this will work. This reachability, these cables, switches, all these devices, this underlying infrastructure will work for the SDA solution as an underlay. Underlay is the underlying infrastructure which is responsible to provide. Underlay is something that is responsible to provide the services to the overlay network. What kind of services? Services such as, for example, reachability. So we have to make the reachability of all these devices, like all these devices that we have in our campus network. All these devices must be reachable from the DNA Center. How we are going to make that reachable? It's up to you. You can use any protocol in your underlay network. You can use EIGRP, you can use OSPF, you can use ISIs, you can use whatever protocol you want to use to make the underlying infrastructure reachable with the Cisco DNA Center. Once these devices are reachable with the DNA Center without redesigning the underlying infrastructure, DNA Center is able, from the DNA Center we can separate our different types of user. For example, there is a concept called VN. We will study about it. Like there is a concept called virtual network. Virtual network allows us to perform segmentation. Like for example, we have corporate users. We can separate those corporate users in a different VN. Then we can have like IoT users. We can have like guest users. So with the help of the VN, actually, virtual network, which is quite equivalent to this thing called VRF, if you know. So VN, like virtual network within like this SDA solution, which is also referred to as like VRF in the traditional networking. So VN basically allows us to separate the users like corporate users, IoT users, guest users, and different types of users without actually redesigning our underlying infrastructure. Our underlying infrastructure will remain as it is. As long as there is a reachability between the devices, it's all good. We do not need to change the underlying infrastructure. We do not need to connect any wire from any to any switch. As long as the reachability is there, it's all good. As long as the reachability is there, we will be able to send and receive the traffic from one point to the other point, from the corporate to corporate, from the guest to guest, from the IoT to IoT, without redesigning our underlying infrastructure. How that thing will happen, we will see that later on.
Surinder?
Yes.
One query. This underlying infrastructure, are we going to build this underlying infrastructure with the Cisco DNA Center, or we will have to do it manually?
Both options are there. We can build it manually, or if you want, like Cisco DNA Center can build this underlay network for us as well. So we have the concept of automated underlay and the manual underlay. Both the options are there.
Okay, so if we are going to use manual underlay, we can use any vendor devices there, right?
Again, as long as the reachability is there, let's say for example, again, we can use any protocol and anything you want. In fact, these devices might not even be the Cisco devices. It's all good. But again, when it comes to the DNA Center capabilities, compatibilities, only Cisco devices will be supported. But again, we can use any protocol, we can use any devices. As long as the devices are reachable to the DNA Center, it's all good.
Okay.
Right. We will
Sir,
discover
I
both
have a
the.
question. We are discussing about this underlay and overlay concept, right? So this underlay is only responsible to establish a reachability between the devices, like, but the
Most
traffic will flow over the underlay or overlay.
we'll talk about that. We'll explore those
Okay,
options later on. This is just like we are
okay,
discussing,
okay.
like how the what options are there. We'll talk about the traffic flow and everything. At the moment, like you can understand the one underlay at the moment, like at this point, yes, underlay will only be responsible to provide the reachability services. Later on, when we enable multicast and everything, then you will notice that our multicast traffic will also go via the underlay, and also different services can be provided by the underlay. For example, when we talk about the AP onboarding, you will notice that the underlay will be responsible to make the reachability from the AP to the WLC and all. So different things are provided by the underlying infrastructure, which we will definitely
Okay.
explore later throughout the content.
Surinder sir.
Yes.
So this underlay network is it means vendor independent or
Later,
means
later. We'll talk about it later. There is a dedicated discussion about the underlay and overlay later on. Like, at the moment we just start talking about how like this SDA solution is going to, build our, like it will be able to perform the segmentation, like without redesigning the underlying infrastructure. What underlay network is there? Whatever underlay network you have, it will work fine. Like you don't need to change anything in your underlying infrastructure. It could be anything.
okay, right sir.
As long as the reachability is there, it's all good. Again, as long as these devices are reachable to the DNA center, it's all good. Because what happens, like when everything is reachable, when these devices, these switches that we have, where we have connected our corporate user, guest user, IoT user, APs and all, like when we actually have connected variety of users here, and all these devices are reachable to our centralized controller called DNA center or the catalyst center, what will happen eventually actually, that without changing anything in your underlying infrastructure, DNA center is going to use a concept of overlay network. DNA center is going to use a concept of overlay. What is overlay? Overlay is something that we build on the top of the underlay. Again, there will be a dedicated discussion about the overlay network, the protocols and everything used to build the overlay network. The point is that if I want to send some traffic from this edge device to this edge device, we do not need to change our underlying infrastructure, because DNA center will allow us to build a logical tunnel, like a logical overlay network from this edge device to this edge device, and we will be able to send our traffic from one device to other device. So the underlying infrastructure will just be responsible to receive the packet and more like switch it or route it towards the desired destination, and that is it. Like this entire network, this entire traffic, this entire end-to-end traffic is basically flowing over this logical network called the overlay network. Overlay is something that is built on the top of underlay. Just like, for example, overlay is built with the help of the tunnels. Just like, for example, here you have two routers. These are connected via service provider, and you want to send some traffic from the LAN network to LAN network. Similar to like this thing called GRE, DMVPN, just like we build the GRE tunnel, just like we build the DMVPN tunnels to transport our private traffic from one location to other location over a public network such as internet and all. So just like this is a concept of the overlay network, here also there is a concept of overlay network. And using this overlay concept, DNA center will be able to send the traffic from the corporate to corporate, guest to guest, IoT to IoT, like from one device to the other device without the need of redesigning the underlying infrastructure. As long as the reachability is there, again, as long as the reachability is there from the S device to S device, as long as the reachability is there from the S device to the DNA center, it's all good. So again, SDA solution is going to use the concept of underlay and overlay. What is underlay? Just to give you the brief idea. Underlay is the underlying infrastructure. Underlay is the underlying infrastructure built with the help of the cables, devices, protocols, and everything, which is responsible to provide this underlying infrastructure is responsible to provide the services to the overlay network. What is the overlay network? Overlay network is a logical network built on the top of the underlay with the help of some tunnels. So Cisco SDA solution is going to build some tunnels from one edge device to other edge device so that it can transfer the corporate user traffic, guest user traffic, and IoT user traffic from one edge device to other edge device, and the traffic will still be delivered from the corporate to corporate, like guest to guest and IoT to IoT. there will be a proper segmentation throughout the SDA fabric, throughout the network, throughout the this entire infrastructure, throughout the campus area network. And we don't need to do any changes in the underlying network. Underlay network is just responsible to provide Underlay network is just responsible to provide the reachability between the devices and the DNA center. As soon as reachability is there, again, it's all good. We can later on we will study. We can create this thing called VN, virtual network, which is quite similar to the VRF concept. So with the help of this VN concept or the VRF concept, we can perform segmentation. We can separate our corporate users, IoT users, guest users. We can separate these different types of users, and the traffic can be delivered from corporate to corporate, IoT to IoT, guest to guest can be done accordingly. And we don't need to put maybe we don't need to put a dedicated interface, we do not need to do any changes in, for example, the underlying infrastructure. As long as the underlay has made these devices reachable, on the top of this underlay network, a logical tunnel will be built, and that tunnel will be responsible to carry the traffic from one device to the other device, from one edge to other edge to the outside to the edge, and all. It all will work accordingly. All that matters, again, repeating myself, all that matters is the reachability. How you have made the reachability, your problem. You can make the reachability in the underlying infrastructure using EIGRP, using OSPF, using any protocol that you know. However, Cisco recommends that if you are building the underlying infrastructure from the scratch, it is a greenfield deployment, like you are building the campus fabric from the scratch, they recommend that you use ISIS. Why they recommend ISIS and everything, so we'll talk about that later on. But they recommend using ISIS, but it's not a hard and fast rule. We can build our underlay network on any technology. We can use EIGRP, we can use OSPF, we can use any protocol to make the reachability between the devices in the underlying infrastructure.
So Surinder, Irshad here. So this yes, ISIS is a layer 2 protocol, not a layer 3. Is it right?
It is responsible to make the reachability, it is responsible to exchange the routes and everything. So how it does that, it is a link layer protocol actually. It works on a classless, CLNS concepts and all. But yeah, this will be responsible to make the reachability between the devices, and the reachability will be there based on the IP, and that's all that we need. We really do not care that this protocol, we don't need to manually configure it actually, because this will be done again by the DNA center automatically. If you are configuring it manually, then of course, you need to do proper configurations of the ISIS, do the necessary configurations and make the devices reachable. But again, we are not going to do that. We will use the DNA center LAN automation feature, and there we will see how ISIS has basically done the configuration between the devices. It is a link layer protocol, but it can carry the routes and everything. So since it is a routing protocol, it can carry the routes, and if it carries the route, then the reachability is there, and the reachability is the only thing that we need at the moment.
Okay.
From the underlay point of view.
When you are talking that under the underlay protocol, and it will go through overlay. So when you are telling when it's the overlay, whether it is the traffic is encrypted or not encrypted.
Tunneled. The traffic is tunneled. Yeah. Again, yeah, traffic is more like tunneled. For the tunneling, we use different protocols. So encapsulation happens, not the encryption.
Okay. So because if encryption happens, then definitely there will be very performance issue, correct?
Performance issue plus additional overhead will be there. Every edge device needs to perform some encryption, then other device needs to do decryption. So those things will be there. But so encapsulation happens, not the encryption.
Okay. Thank you so much.
Right. So again, main point was we do not need to change anything in the underlying infrastructure. As long as our underlay is reachable, it's all good. We do not need to redesign the underlying infrastructure. As long as these devices that we have, these are reachable to each other, these are reachable to the DNA center and everything, it's all good. We do not need to change anything in the, maybe you already have your underlying infrastructure up and running based on EIGRP, it's okay, it's fine. All you need to make sure that these devices are reachable to each other and these devices are reachable to the DNA center. Once you make sure of, make sure of that, then we can, build. We can go on the DNA center. We can go on to this catalyst center, and we can use the concepts of VN. We can use the concepts of tunnels to build the logical, connections from one S device to the other S device. Basically, we will be able to build the tunnels from one S device to the other S device, which of course we'll call overlay, and we'll be discussing about it later on. Not only like underlay overlay, like we also have the concept of policy. One of the major problem that we have in a traditional network is the use security. In the traditional network, like we can configure things such as, for example, VLAN. We can configure things such as, for example, ACL to achieve some sort of segmentation. If we have a switch and we have two departments connected onto the switch, we can separate these two departments with the help of a concept called VLAN. If we have a router and we have two interfaces here, we do not want these two interfaces to communicate to these two interfaces, then we can configure this thing called VRF. So with the help of concept of VLAN, with the help of the concept of VRF, with the help of the concept of ACL, we can basically control what devices can communicate with what devices and what devices cannot communicate with what devices. We can configure different types of ACL. If you remember, we can configure ACLs based on IP, we can configure ACLs based on MAC, we can configure the ACLs on the switches and all. We can configure like different types of ACL on the network. The major challenge with the ACL based like security is the scalability. Like in your production environment, you might see an access control list where thousands of lines are there, thousands of statements are there in that access control list. That ACL is being used to enforce the security in your production environment, and that ACL has like thousands of lines, 2,000, 3,000 lines are there in that particular access control list. Now let's say we have to add a new line, or we have to remove like a particular line from the access control list. There is always a risk of like, deleting accidentally the entire ACL. Like we ideally like, edit the ACL in the notepad and then we do copy paste and everything. So there is always some challenge while managing, while editing, while reconfiguring that access control list in a production environment that has like tens of thousands of like statements. VLANs, you already know. VLANs like are very limited. 4094 number of VLANs are there. Problem with the like traditional VLAN or ACL based security is that these solutions like are there, it's fine, but these might not scale very well in a large or very large campus deployment. You have like maybe for example 50-60 branches all over the world. You have like 2-3 headquarters. You have like 3-4 data centers and all. And on every place we have configured the security based on the ACL, VLANs, and those things. These things might not scale very well in a large to very large deployment. To enforce the security, we already are using some other concepts in a production environment. We use things such as, for example, we can use, so for example, if you want to control who can access the network resources, who cannot access the network resources, we can configure things such as, for example, AAA. AAA functions basically are managed by the nowadays like identity services engine. Basically, we can, instead of configuring security based on the IP address, instead of configuring security based on the VLAN and those things, what we do actually nowadays, we configure the security based on the group based, like group based access control. Group based access control is a concept that we use in modern day network. So for example, when a user joins a network, user will log into the network, user will try to access the network resources. User had to supply its username and password. Once the user supplies the username password, the authentication, authorization, accounting functions will take place. The user will be authenticated, authorized, and then later be accounted, like later will be monitored like what the user is doing. So we are going to go on a AAA server. We are going to create the policies for authentication. We are going to create the policies for authorization, and then we can configure things such as accounting on a AAA server. So what happens, like when the user logs in, when the user tries to join the network, the user will be asked for the username password. When the user has supplied its username password, that username password will be checked from our database, and then a user will be made part of a group. For example, user is identified to be part of the HR group. Then another user joins in. This user supplies its username and password. When the user connects itself into the network, again the verification and everything will happen, and the user is identified to be part of, let's say, for example, IT group. So basically, users are like in modern day network, when it comes to enforcing the security, we go for this option called group-based access control. In the group-based access control, what we do, we group the user based on things such as, for example, department. So we have the username ABC. When this user joins the network, it will be made part of the group HR. When the user joins the network, it will be made part of the group like IT. And then we can configure the configure the policies. Actually, we can configure the policy that okay, HR user cannot communicate with the IT user. Basically, we can configure group based policy instead of configuring the policies based on the ACL or based on the VLAN. Nowadays, we go for this option called group based access control. In the group based access, and this group based access control concept, actually, like it can be done from this DNS center itself. We do not, like, what we do. This is our DNS center. This is our Catalyst Center appliance. This is our DNS center appliance. This DNS center appliance is integrated with our identity services engine. We have ICE running somewhere. We have DNS center running somewhere. ICE and DNS center can communicate to each other with the help of this concept called API. Later on, we will cover about it. We'll cover this API concept. So REST-based API or RESTful APIs, whatever we call that. So we have a DNS center controller. We have the identity services engine. Nowadays, like when it comes to security, at least in Cisco devices, we enforce the security. We enforce things such as, for example, AAA and everything from this product called identity services engine. So we have ICE deployed somewhere in our network. We have DNS center deployed somewhere in our network. We have made the DNS center and ICE reachable to each other. We have enabled a few services, and our now DNS center can communicate with the identity service engine with the help of the API. Once the integration is done, once the DNS center and ICE are integrated, we no longer need to go to the identity service engine to create any policy, any group-based access control policy. We don't need to do that. We can actually, from the DNS center itself, we can just click on that. We can just go to the policy, and right here we can configure this thing called group-based access control. You click on this, and this tab that is opened in front of you, it is quite similar to what you get in the identity services engine. It is quite similar to what you get in the ICE. From ICE also, from the ICE dashboard also, you will be able to actually create this thing called groups. You can create the groups and you can configure these group-based policies. Same those things can be done from here, from our DNS center dashboard. I'm not saying that ICE is not required. ICE will still be required. Eventually, it will be ICE who is going to push all the things on the devices. DNS center is just acting as the front end. DNS center is just acting as the front end, like we are going to do everything from the DNS center, and DNS center is going to push those things into the identity service engine, and it will in fact be identity service engine who will be responsible to enforce the policy throughout the campus area network. But we don't need to log in onto now two dashboards. We can still stick to the DNS center, and we can do like a lot of things on here itself regarding the security. For example, here are your groups. Right from here, we can configure the groups. We get the same option in the identity service engine as well. You can log into the ICE, you can log into the identity service engine, and from there also you can create these groups. These groups are called security groups. Security group, scalable group. We call them security groups in case of security identity services engine. When it comes to the DNS center, we call them scalable groups. We call them like scalable groups. Basically, again, concept remains the same. Group. We have created these groups, like we have configured these groups of like auditor, bring your own device, camera, contractor, developers. We have configured these different groups. Then we can create the policies for these, like for example groups. I can go to the policy and right from the DNA Center dashboard, instead of configuring IP based or URL based access control, I can still do that. I can still configure the policies. I can still configure the security based on the IP address. I can still do that. I can still configure the ACLs. I can still configure the ACLs right from here. But a better option would be to go and configure this group based access control, where we are going to create our.
Sorry to interrupt you. I have a question. So when we are creating this scalable groups or security groups, like we need to add devices manually to that particular groups or
Later. We'll see. We'll discuss. This will be like, based on the policy itself. Like you don't even need to do that. You can just set the mode of authentication, and then you can just once the user tries to join the network, it will be asked for the username and password, and then based on whatever policy we have configured, things will work. Yeah, we'll do that.
Okay, and one more question, sir. Like in this SDA, like ICE, is it mandatory to use ICE only, or we can use some third-party kind of Aruba ClearPass kind of solution, or without
There
ICE?
are generic AAA servers are also available. Cisco ICE is also supported. We can have generic AAA servers, or we can have ICE.
Okay.
Right. So what I'm trying to say is that instead of configuring like IP and URL based access control, what you can do, you can configure this group based access control, where we are going to create the group of users and then later on define the policies for those user group. For example, I can define that for example, contractors that we have or developers that we have, developers cannot have the access of the lights, or developers cannot have the access to the developers cannot communicate with the guest users. So I can just click on that. I can enable the policy and I can define that deny IP. Deny IP basically means like I'm going to deny everything from the developer to the guest, and just click on here like the done. Just let me just, yeah. So here I just configured a new policy, like I said, developers, and they are not allowed to communicate with the guest. All I had to do is to just click on that matrix, that policy matrix, and then I had to just define here what do we want to achieve. And then we can just deploy this policy, deploy now, and then done. This policy will get delivered onto the identity service engine, and the ICE is now going to enforce this policy throughout the network. Again, we are doing it. We are still doing it on the ICE. Like it's nothing new actually. It's nothing new actually. It's still like we are still doing this thing from the ICE nowadays also. But the point is that the point is that now, if you want to enforce the policy in your campus area network, you can do that once the ICE integration is done with the DNA Center. You do not need to log into the identity services engine and create the user group and policies. Instead of that, you can just stay on the DNA Center, and from the DNA Center itself, you can go to the policy, you can go to the group based access control, and right from here you can configure the policy, you can configure the user group, and you can configure the policies for the group. Again, we will discuss more about it, but the point remains the same. The point remains the same that here Cisco DNA Center automates the user access policies, so the organizations can make sure that the right policies are established for any user or device with any application across the network. We have the concept of unified policy for the LAN and wireless LAN. We can have one policy for the LAN user, and the same policy will be applied for the wireless LAN user. No matter if the user logs in from the, no matter if the user connects itself from the LAN or the wireless LAN, same policy can be applied for the user. Yes.
Yes, Surinder, one query. When a desktop boots up, okay, or laptop boots up, when I have connected that one, so it will get an IP address, right, from the DHCP server.
It will get the IP only again. That is again dependent on what type of policy, what kind of authentication mode we have applied. So based on what kind of authentication mode we have configured, it will like it will be given the IP. Certain protocols might be allowed or certain protocols might not be allowed. That will be based on what type of authentication we have enabled. Otherwise, you will not even get the IP.
Okay, so when it boots up, we get the login page. Now that in that login page, I'm giving my AD domain ID and password. Okay. And that is this ICE is this patched up with the AD server. or how
Yes,
it
you
will
can. Yes, yes. That is again, that is the ICE part, which we will not look up into. What we will do, we can create the user ID and password on the ICE itself. You can create the user database on the ICE itself. Otherwise, ICE can also be integrated with an external AD server. So when you, for example, supply your username password, either ICE can look up its own database or can go to the AD server for the user password lookup. So both the options are there. Whatever suits you.
Okay, if AD server is not there, only ICE is there. So I will have to log in twice, or how it will be that AD
Yes, you have to
server
go on
as
the
well
ICE
as.
and you have to create the user database there.
So
You have to.
when a user boots up, okay,
Hmm.
he is connected there. He is connected his laptop or desktop. So you will have to log in twice in AD server as well as in ICE.
User will just supply its username and password. That username password will be given to the AAA server, and AAA server, whoever is the AAA server, will be responsible to perform the authentication of that user. And if that user, if that AAA server is basically ICE, then the request and everything will go to the ICE, and ICE will be able to. User doesn't need to do anything. User just need to supply its username password.
Okay. No, for AD he will have to he will have to give user ID and password once, and again for ICE he will have to give it again. It is like that
You will
twice.
all, from the user end point of view, you don't have to do anything. From the network administrator point of view, if you are going to use this Active Directory, if you are going to use AD for user authentication, then of course you need to set up AD. You need to integrate that AD with the ICE. We have to do
And
it from the. If
if
ICE
I
is not
don't,
there, then you can do it from the local. If the AD is not there, then you can do it locally from the identity service engine itself. But we
okay,
have to do it. User does not have to do anything in this.
okay.
User boots up, user will just give its username and password. That username, name and password will be given to the AAA server. Either that now can be authenticated from the local database that we have configured, or if we have integrated, or if the network admin has integrated AD, then the user authentication can be done from the this Active Directory. But from the user point of view, user does not need to do anything. User just need to supply its username and password. No
Okay,
matter if the user.
yeah, another query about the policy. So whenever we are configuring any policy, those policies will be downloaded to that edge node.
Yes. Policies will be
So
evaluated based on the tags and everything by the edge node. Yes.
edge node. So those policies will be downloaded in that edge node, or it will be in its RAM or in its current configuration, where it will be that those
It will
policies.
be again. It is again dependent on what kind of authentication policy authentication technique we have configured. But again, once we enable proper authentication policy, the policy will be there on the devices locally. You will be able to see the tags and everything on per port basis. When the traffic arrives accordingly, you will be able to see the tags, the policy, and everything on the device.
Those things will be in RAM. If I boot up, then it will go. Boot the edge node, it will go, or those things will be in configuration. Even if you boot up, it will take back.
No, it is more like when the interesting traffic arrives, that is based on again the concept of classification, propagation, and those things. Like we'll discover it in the later policy tab.
Okay,
Those things are dependent on the concept of classification and the propagation of the tags and those things. So in the ICE section we will cover it.
okay.
Right. Right. So fine. So again, we can configure the policies on the DNA center, and as soon as we click on the deploy button, those policies will be given to the identity service engine. Again, how far away your DNA center and identity service engine is actually, that is the latency between the two will be the factor in deciding how fast the policy gets delivered on the identity service engine. But again, it's almost immediate. We do not have a lot latency between the DNS center and ICE. So as soon as we click on that deploy button, you will notice that the DNS center will push the policies towards the ICE, and ICE you will be able to see all those policies and the identity. So almost I would say immediate.
Surinder, here I have one query. The configuration. Suppose I am configuring automatic underlay. So DNA Center will push those configuration to those devices via netconf, right?
Yes. Again, it can do that with the help of the netconf, SNMP. Different protocols are there.
Okay, now I have configured this DNA Center policies in DNA Center. So DNA Center will push those policies via RESTconf to ICE, correct?
No, it will not do that. Other services are there for the same.
Okay, but you told us, right? The DNA Center and ICE communication happens via RESTful API.
APIs and other things are PX Grid, and those services are there. Again, these things we'll discuss when we talk about ICE. We have PX Grid services, we have like ERS, external RESTful APIs, and other things are there. So again, APIs are one thing, then we have like the PX Grid services that allows the integration to happen between the devices.
Okay. Now, next question is when the user will connect, these policies will be pushed to those devices, to the edge node via ICE, from ICE or from DNAC. Who will push?
ICE.
ICE will push.
Yes.
And how ICE will push that policies?
We'll discuss it in the ICE section.
Okay.
We'll see that in the ICE section.
Okay.
Yes. Right. So when it comes to DNA Center, when it comes to the SDA solution, what things we require? We require, like, overall what things we require. We require things such as, for example, to build an SDA solution, like if you want to build an SDA solution in your campus network, what things you require? You require like a few things like a controller based architecture, and just another way of saying that you require a controller, a device which is responsible to do all the functions from one centralized point, then someone to enforce the policy. Again, this is going to be, typically it is going to be our identity services engine. Network fabric is like the campus fabric, we call that campus fabric. We will require a campus fabric. Fabric is typically, the term fabric generally it refers to the overlay network, the overlay network that is built on the top of the underlying infrastructure. So the campus fabric, again, managed by the DNS center. This campus fabric will be built and managed by the DNS center. And this SDA solution also offers the programmable interface infrastructure, which basically means it allows us to have these other third party, like automation tools. If you are good with the automation programming, if you are good with the scripting and all, you can use these automation tools to send a variety of API calls. You can do Python scripting, you can run the script, and based on the things that you have written down in that script, DNS center can take that input, and then it can push necessary configuration on the devices accordingly. So not only we have the GUI, but we also have programmable infrastructure. We also get like the support of the APIs, and with the help of the APIs, we can again do almost everything that we can do, like with the help of the GUI from the graphical user interface. So if you are good with development, if you are good with programming and everything, you can create the codes, you can create the variety of API calls, and from those API calls you can actually also manage the entire SDA solution in one go.
Surinder, one question. Sorry, I have one question here. Like when you say network fabric and switch fabric, both the terms are same or different?
The term switch, not the switch fabric. That switch fabric is fabric. Basically, I'm generally referring to the overlay network, which is built around the campus area network. So typically, network means like the campus area network fabric, the CAN fabric, the campus area network fabric that we are referring to. Switch fabric is something specific to the switch fabric, means like internals, how the switch is going to switch the traffic from the line card to soup card, and those. Not that. Basically, the network fabric, the campus area network fabric, the overlay that is built on the top of the underlay network. That one.
Okay. One more thing here. Like when you say last question with respect to Pradeep, design with respect to the ICE. Like suppose I'm running a small company. Okay, I have a DNA center, but I don't have a ICE. Okay. So is it possible my AAA is done by DNA?
No.
It's not possible.
No, ICE, any AAA server, or maybe the identity services, something from the authentication and policy server will be required. Like DNS center itself will not act as the authentication and policy server actually.
Okay. So we need for any type of AAA, we need eyes.
Yes. In fact, it will give you warning as well. Like if you do not have right here, it will give you the warning that ICE is not integrated or AAA server not available like that. So it will give you the warning as well. So you will not be able to do the policy thing from here actually.
Okay. Thank you so much. Yeah.
Right. So to build the SDA solution, we require a controller. We require someone to enforce the policy. We require a fabric. Fabric generally means like the overlay, and we have a programmable infrastructure, that can be managed via the DNA center. And again, DNA center itself is programmable. That means like we can use the concepts of APIs, Python scripting, and those things to give the instructions to the DNA center, and DNA center will push that intent onto the devices respectively. Basically, these are the components that we require. Like we require a controller, we require a policy enforcement engine, we require the campus fabric, and then we require some programmable interfaces that are basically available to accept the instructions from some other solution. Right. So within the scope of the SDA solution, these are the things that we need. From the design point of view, these are the devices, these are the things that we need. We need like routers and switches. We have the routers and switches. Again, access point and wireless LAN controller. We require identity services engine, and we require our controller, DNA center or catalyst center. So we at least require these components to build an SDA solution. Again, all these things should be from the compatibility matrix. All these things should be compatible. Yeah. Hi, let me know.
We use now Ansible to configure also to see also the firewall. It's possible on the DNA center to import also the firewall that we have.
Firewalls, again, we can create the profiles and everything for the firewalls. There are certain firewalls that are compatible with the DNA center solution. So I would say yes, but when it comes to the fabric and everything, we do not have much options.
Okay.
But we can create the profiles for the wireless. We can create the profiles for the like the firewalls and all. Certain firewalls are supported, so definitely like some configurations can be pushed there. But it's more like by creating a profile and templates, not like by going to the campus fabric and doing the things. So again, yes, there is a support of certain firewalls, but again, what level of support is there, that will vary. Not everything you will be able to do from the DNA center regarding firewall, or in the not a lot of things, or not everything you will be able to do from the wireless point of view also. Like you can do you can have the wireless support, but again you will notice that eventually the wireless LAN controller will be the one from where we will be doing all the kinds of GUI things from the wireless point of view. Similarly, like we can create the profile for the firewall, we can push certain configurations onto the firewall, but eventually we will log into the firewall, and then we will do the configurations from there. But we do have the support of like certain things when it comes to firewall here. Here. So we have like, if you go to the DNA center, again, we will explore this network profile option later on. So you can go here and you can create a few things regarding the firewall. You can create a profile for the firewall, and definitely you can push it on the supported firewall, compatible firewall. But again, what level of support is there, that has to be like discovered. That has to be like, checked actually.
Thank you very much.
So we have routers, switches, we have APs, WLCs, we have IDs, we have DNA center, and all of these things should be from the compatibility list. It's not like you can just plug in any router, any switch. It's not just like you can purchase any AP, any WLC. All these things should be from the compatibility list. Now, what is that compatibility list and another thing? We will talk about that in our next section of the architecture, which we'll cover just after this basic things is done. Now, these are the devices, these are the hardware devices that we will require. Then we will do the connection, we will build our underlay network, we will make things reachable to the eyes, we'll make things reachable to the wireless LAN controller, we'll make things reachable to the DNA center. Once all the reachability and everything is there, then we will be able to build our logical overlay network on the top of the underlay network. Then we will be able to enforce the security based on the eyes. Then we will be able to manage the devices with the help of the wireless LAN controller. Now, what protocols we need? Again, we can use any IGP when it comes to making the reachability in the underlying infrastructure. We can use any IGP. However, they prefer ISIS. Why? Later on. Now, when it comes to this is like the underlying infrastructure. For the underlying infrastructure, we can use any IGP. But when it comes to the overlay network, when it comes to these tunnels that are built on the top of the underlay network to carry our traffic from one point to other point and everything, these are the things that we use in the overlay network. These are the things, these are the protocols that we say, these are the protocols that we use in the overlay network. We use protocol called VXLAN. We use protocol called Lisp, virtual extensible local area network, locator ID separation protocol, and Cisco TrustSec when it comes to policy. So in the overlay network, we have three things. In the overlay network, we have the control plane, data plane, and the policy plane. We have like control plane, data plane, and the policy plane. Management plane itself is the DNA center. So in the overlay network, we have this thing called data plane. In the overlay network, we have this thing called control plane. And in the overlay network, we have the policy enforcement engine, basically policy plane. In the SDA solution, data plane is built with the help of the VXLAN. In the SDA solution, control plane is built with the help of the protocol called Lisp. And in the SDA solution, the policy is enforced with the help of CTS, Cisco TrustSec. These things will be discussed in the underlay overlay section later on. In the network layer, we will talk about it.
Surendra sir. So like in SD-WAN, all those WAN edge routers are interconnected through IPsec.
Yes.
Same way here, these means all these switches, they are connected by this ISIS.
Underlay, yes. Recommended. You can use any, but preferred. Yes.
And for overlay, what they use?
Here. VXLAN, Lisp, and CTS. VXLAN, virtual extensible local area network to carry the data from one end to other end. Lisp as the control plane, more like, we have this thing called routing protocols and all. So when it comes to SDA control plane, they use this concept of Lisp. And then when it comes to policy plane, they use this concept of. So these are the overlay protocols. Three things they use in the overlay.
For these edge switches, all these means edge devices, these switches.
Edge device, border, control, everything. Like, these three things are used between the edge to edge, edge to border, edge to control plane, those things like, so these three things.
Okay. Thank you.
So this is more like the underlay and this is more like the overlay. Again, we will discuss about the underlay overlay in very detail in our network layer later on. So be patient. So these are the like components that we require to build our SDA network. We require router switches, access point WLC, our policy enforcement engine, centralized controller, protocols for the underlay network, and protocols for the overlay network. At least these things will be required to build our SDA solution based on DNA center or Catalyst center appliance.
Surrender sir. There's one more little thing. Means these edge devices, do they use this Lisp to reach the DNA center also?
No. Again, this thing we'll discuss later on. No, they do not. They do not. That DNA center reachability is from the underlay network, not from the overlay.
Okay.
Right. Data will not flow from the DNA center, so they don't need to use Lisp or VXLAN. In the overlay. So DNA center is basically made reachable from the underlay network. Again, we'll discover that. But it's from the underlay, not from the overlay. Right. So what benefits we get once we build our SDA solution based on this DNA center and all that? Once we build our SDN solution, specifically we are talking about here the SD-Access solution. What benefits we get? The very first thing that we get is the complete visibility. We can identify and group endpoints, map their interaction, and define the policies from one centralized point. We get like better visibility of the entire network. We can see that right here. For example, this is our DNA center main dashboard. I can go to like policy dashboard from here. I can go to the group-based access control. Here we have configured our security groups, also known as scalable groups. Here we have configured our groups, and here we have configured the policies for the groups. Once we have configured the groups, once we have configured the policies for the group, and the users, they send the traffic arrives on the switches use these policies to send and receive the traffic respectively, all that. Once that happens, we can go to this overview tab. I can go to this overview tab, and right from here we can do all sort of monitoring. For example, I can click on the security group, and I will be able to see what kind of traffic is moving from what particular location. We can do basically some sort of monitoring here. That's what I'm saying. I'm saying that here, from here itself, we can do some sort of monitoring from this dashboard itself. We get like the traffic flow information for the security group. From this overview tab, actually, I can see from this overview tab here, from this overview tab, I can see that we have configured 27 security groups, and I can click on these. Again, these things will be discussed later on. We can click on this, and then we can see, like, for example, guest users. For the guest users, we have configured a variety of policies. So for the guest user to the guest user, is the communication allowed or not? So I can just click on that, and I can see the policies that we have configured for the guest to guest. So for the guest to guest, what policy is there, what policy we have configured, what we have allowed, what we have not allowed, those things we can check from here. We can click on view contract. I can see the contract, like for the traffic flow. Then we can go to the, basically all sort of monitoring we can do. A lot of monitoring we can do right from here. Like when it comes to the traffic flowing from the one group to another group, we can analyze that traffic. We can basically discover different types of traffic right from here. This point, we get visibility. We can identify and group the endpoints, and then we can map their interaction and define the policies for the same. We can I'm not saying that we can do a lot of things, but again, we can at least see what policies are pushed and what things we have. We can create the report, we can download the report, and those things, like we can do all sort of things actually. We get an overview of the flow that is going from one group to another group. And better than this, like if we are talking about the since we are talking about the monitoring, we are talking about the visibility of the campus fabric. We are talking about, in this point, we are talking about like the visibility of the campus fabric, visibility of things. Just go here, just go to this assurance tab. You can just go to the assurance tab. You can click on this assurance tab, and you get these different dashboard. You get the health dashboard, you get the issues and event dashboard, sensors, Wi-Fi 6, rogue and wireless intrusion prevention system, POV, a lot of things. We can create our own custom dashboard as well, by the way. In the assurance, we have a lot of things from the monitoring point of view. Let's click on the health dashboard. Once you click on the health dashboard, it will give you the overall health of your network. Or this is the overall health of the network. This is like how many number of network devices are there, how many of those devices are healthy, how many those routers are there, switches are there, wireless devices are there, access points are there, how many of them, how many wired clients are there, wireless clients are there, active, connected, all sort of like basic monitoring you can do right from here. This is the overall health of the network. You can click on the network, and this is for past 24 hours. We can get like past 7 days, 24 hours, 3 hours. We can go custom start date and end date. We'll discuss later on in the assurance tab. Then we can go to the network dashboard. In the network dashboard, this is what we refer to as time travel. Like we can see that from 3 p.m. I can time travel. We can see that if like from 3 p.m. actually to 3 p.m. to like 5 p.m. 5 p.m., 5:30, whatever it is. I can see from 3 p.m. to 5 p.m. what issues, what things, everything was there regarding those clients and everything. This is like the network health. This is the network health from 3 p.m. to 5 p.m. How many devices were there, the core layer devices, distribution, access, wireless controller, link utilization, top clients, AP, up, down, and those things. These are the devices. 16 devices are there and all. We can basically check. We can check the overall network health from this network dashboard, network health dashboard. Since we are talking about monitoring, since we are talking about visibility, we get good visibility, we get better visibility under the assurance dashboard. And just click on any device. Let's click on this device. If I click on this particular device, just click on that device, it will open that device 360. Device 360 basically means like 360 complete information about that particular device. In fact, we can run the commands right from here, whatever commands like, show. Again, here, since it is D-Cloud DNA Center, not all the commands will be supported, but we can do like things such as ping. We can do, if it was a real like DNA Center, I will be able to execute all the commands right from here. We don't need to log into the devices one by one, since we are talking about visibility. This is particularly for that particular device. This is like device model, management IP, location, software version, role, for how many days it is up and all, reachable. Click on the view all detail and it will show you all the other information. We get tons of monitoring feature. In fact, how the neighbor topology is there, that can also be discovered. This is like, it is using CDP and those things. So it can discover the network topology and it will give you the information about the devices as well. Right? What variety of events have occurred? What variety of events have occurred onto that device? Those logs and everything, we can check it from here itself. We can check like the logs and everything right from here itself. We can do the ping and trace from here itself. We can see the user application experience from here itself. We can check the device information, interface information, POV status. Tons of things are there when it comes to monitoring. When it comes to visibility, we have tons of features available here. This is, I believe, like they are running in their own environment. It is in a sandbox environment, because every time I do something and then I go again, then the informations are like gone. So I believe they are running in some sort of sandbox environment. This is publicly open. This is like D-Cloud. This is like just for the demo purpose, So we'll talk about how can we access it actually. Today we'll see that. Right, and okay, this is network, this is device 360. Do not forget about the client. Just click on the client. You can click on the client and it will give you all the client information right from here itself, like how many wired clients are there, how many wireless clients are there, and just scroll down. Since again we are talking about the visibility, you can get like information about each and every client right from here. For example, let's go for John PC. I click on this, I get client 360. So that was device 360. This is client 360. So in last 24 hours, what is the client information? I can in fact do the packet capture right from here. It says intelligent capture. Later on we will talk about it, like whatever it is. So we can do some sort of packet capture right from here itself. Okay, this is the basic information about that client. That client is Linux workstation, the OS, MAC address, IP address, IPv6 address, VLAN number, status, capability. Again, a lot of information we get from here. And just scroll down, you get like the summary, you get the issues, how that client got onboarded, everything like, when it comes to like monitoring, when it comes to visibility, we get like a lot of option.
Check that the antivirus is updated on the client or all the things also.
Which one?
You can check antivirus and all that features. Windows updated or not.
That thing, I guess I have to see. I have not. I have to explore. I have to see. I have not seen that. Can we check if the Windows update is there? Oh, I have to check. I have not seen that actually. I have not seen that. I have not looked into that. I will see. Yes, you go to the network devices and you can check the same information for like access point. You can check the same information for the wireless LAN controller. You can check the same information for the router switches. Like again, you can check these kind of things for all the type of network devices and the clients. It just hanged. Right, so you can go to the network dashboard, and from there you can you can check the information about the variety of network devices that we have. So yeah, that's possible. That's possible. I will open again. Right, so again, when it comes to visibility, we get better visibility. Like and you can see that I'm not using any other monitoring tool also. We are still able to get all this information right from the DNA Center itself, right from the DNA Center dashboard. And let's not even talk about this assurance, issues and events. You go to the issues and event. Here you will be able to see all the ongoing issues and backend events that have happened. So here, like how many open issues are there, issues that have been marked as resolved or ignored. So you can see that. So total 25 issues are there. Okay, I can these are 25 issues. DNA Center was able to detect like these 25 issues on the devices. Some are priority 1, priority 2, P1, P2, P3, P4 issues. Let's click on this issue. This is like a P1 issue that says that the layer 2 loop symptoms. So I will click on this issue here. So it says that it is a P1 issue, and the issue is that layer 2 loops has occurred somewhere. Like somewhere, DNA Center was able to detect a loop actually in this location specifically. In this location, in this device, in this location, in this device, 9300 catalyst switch, actually a loop has occurred. Looks like a loop has occurred. The host flaps observed in one VLAN, like in some VLAN, the MAC address is flapping, and when MAC flap happens, it's mostly because of a loop in a switching network. Right, so you click on that, it will give you the information about that issue in detail and everything. Right, and not only that, this is okay. This is like the issue and all those things. That's fine. Just click on this root cause analysis. Click on that. Run machine reasoning. Click on that. It will use its artificial intelligence machine learning capabilities. Whatever commands we will run to find out like where the loops are, how to resolve the loop and everything, whatever things we will do, this actually can do with the help of this machine reasoning engine. So done. It found out that there is a loop in the VLAN 31. Because of that, MAC is flapping between the interfaces. And what you should do, enable STP for the VLAN 30. Looks like somewhere the STP for VLAN 31 is not running. Because of that, a loop has occurred. So on the devices, you should enable STP for VLAN 31. It can use. This is like, this is the tissue that we were talking about. This is the operational challenge that we had earlier. Some user is reporting they are not able to access the network resources, and we had to do the T-shoot. We found out that the MAC address is flapping on multiple ports. We found out that MAC address was flapping on multiple ports because like the spanning tree protocol was not running. Then we need to go on all these devices and then enable the spanning tree protocol for VLAN 31. It will take some time to log into all these devices, check what problems are there. DNA Center, like this machine reasoning, artificial intelligence, machine learning capabilities, they can do it for you. They can just tell you that, okay, the loop has occurred and the loop can be resolved with the help of this thing. Good thing that at the moment they do not have the button here that you can just click and it will enable the STP for VLAN 31, but who knows, maybe later on they will do that as well. At the moment, we still need to go on all these devices and enable the STP for VLAN 31. Maybe later on they will just add one button here, and then they will just click on that button and it will enable STP for VLAN 31. So the point is that not only visibility, we get the visibilities on the devices, we get the visibilities on the clients, we also get the visibilities on the issues that are there in our different sites. And not only we get the visibility, we can also use the machine reasoning capabilities of the DNA center, and it can in fact give you the possible reasons of the issues that you are facing and possible suggested actions as well. That's why it's 30-35 gig in size. This whole image, the DNA center, is approximately 30-35 gig in size. It requires a lot of resources actually when it starts running because of these features. This is like visibility on the client, visibility on the devices, visibility on the issues. Also, we can do packet capture, we can analyze the traffic. We have tons of options, which of course we will discover in our assurance dashboard later on.
We need an extra hard disks over there or not?
Later on, we'll talk about the when we talk about installation of the DNA center, then we will see how much resources it requires. And again, no need to tell you again, group-based access control. We can go to the DNA center, we can go to here, we can go to the policy, we can go to the group-based access control, and instead of configuring the policies based on the VLANs and ACLs, we can configure the policies based on the group. We can create the scalable groups, also called security groups, and then we can create the policies for these security groups right from here. Policies will be consistent throughout the network, no matter how many sites. So currently, for example, here in this dCloud DNA center, we can see that they have approximately 121 devices across 62 sites. There are 62 sites that are being managed by this DNA center, and there are approximately 121 devices all around the world. And for all the devices for all the sites, we can configure the policies right from here. So policies will remain consistent throughout the network, no matter if the network is in one location or in another location. Policies will be consistent for the wired and wireless. If the user joins, the way wireless works in the SD is a little bit different than the traditional wireless. We'll talk about that later on. So when the user joins and user tries to connect itself to the network using wired or wireless technology, doesn't matter. Same policy will be applied for both. How? Later on. The point is that we get like these like clients can move from one point to other point, like clients here again, features such as client mobility. Client is moving from one switch to other switch, and policy is moving along with the user. Like we do not need to configure a new policy for the user when it connects to the switch number 4. No, we don't need to do that. When the user moves from one switch to other switch, when the user disconnects itself from the one switch and connects itself from the other switch, policy will remain same. Because the user will supply the same username password, user will be authenticated via the same AAA services that we have, and the same policy will get delivered for the users. In fact, if we have multiple access points and we have configured things such as roaming, user will not even be disconnected from the wireless network, because APWLC, the whole purpose of the APWLC is to have a very big disjoint a wireless network. So user can roam from one switch to another switch without even having any issues.
So what in case, Surinder, if the user is connected on one switch on a VLAN number 10, and when he connected to a different floor on a VLAN number 20?
It will not work like that actually. It will not work like that. We have the concepts, things such as we have the concept of like anycast gateway. So, but the point is that if the user even roams from one location to the location, from one switch to the switch, it's a VLAN membership and everything will still remain exactly the same.
So I'm talking about the wired user. I understand
wired user. Yes, wired user. Yes, wired user. The VLAN membership, the gateway, IP, MAC, everything will remain the same. User can move from any switch to any switch, like from wire to wire, no problems. For the wireless, of course, it's there. But if the user disconnects itself from the wired network and connects itself on the fourth switch, when the user connects itself on the fourth switch and then it, the port comes up, user basically gets authenticated, authorized and everything, you will notice the same VLAN, same gateway, same MAC, everything is same. Like you do not need to worry about like roaming in case of SDA, no matter from the wired and wireless point of view. Both are supported, both works fine.
Surrender sir, does it use VMPS kind of things for this purpose?
No. It uses like, again, later on, we'll talk about, like, it doesn't use VMPS, it does not use, it uses AAA in short, from the AAA we are going to configure the policies and everything. So and we are going to enforce the AAA settings onto the ports. So whenever the user connects itself on the switch number 1 or switch number 4, you will notice that the user will be given the same VLAN membership, user will be given the same, like, gateway IP and all those things will remain the same. User can roam from anywhere to anywhere, no problems at all.
But strictly on the basis of the VLAN, right?
Strictly based on the VLAN, VN. Yes, like VN. VN is the much more correct word. Like user can roam from one location to other location. It will remain part of the same, like, VRF or VN. And since it is part of the same, since the user is part of the same VN, it will always be assigned the same, like, gateway IP, MAC, and those things.
So VN, you are using the terms the same as like a VLAN.
VLAN, VRF, kind of same. Actually, VN means VRF.
Oh.
Eventually, DNA Center will push VLANs. That's correct. But that VLAN will be part of a certain VRF. So interface VLAN, IP VRF, and those things. So no matter the user connects itself like anywhere, it will. If the user is part of a certain VN, it will always get the same gateway, IP, MAC, any cast gateway, and those complex like some concepts we use actually. So that user can roam from anywhere to anywhere without any problem actually.
So means sir, so this means that this removes the that thing, that means we used to give the static IP to some of the things. Now there's no need to give the static IPs and all.
It means you do not require, you don't need to actually, honestly, you don't need to do that. Because like if the user is connected on the switch number 1, even then it is getting the same, like, same network IP gateway and all those things. And if the user connects itself on the switch number 4, then still the same. So definitely I would say not.
Because earlier there were things like there were kind of some printers and some other these
those things, those things we can put in one VM, like here. Those devices we can put in one VRF, one VM, and they will just be connected there. Like their gateway and everything will always remain the same. They will get the IP from, again, that is basically the same, like we can configure the policies and everything. Like, we can put it in different VM and allow the communication between the devices.
So this thing, this network is virtual, right? Means it's like we used VLANs, this VM, or it is different.
VLAN, VN, VRF. Like, eventually at the end of the day, it will be VLAN and VRF. They call it VM, but eventually it will be VLAN and VRF.
Okay.
Two things.
Okay.
So is it a mix of both?
Yes. Yes. So again, it will be a little bit early to go through in the technicals, but yes, it will be a mix of both. Like VLAN will be there. Basically, DNA Center will push a VLAN onto the switch, right? It will make the port part of that VLAN. Then it will configure an SVI, and it will make that SVI part of a VRF. So yes, VLAN and VRF, both.
So Surendra, IoT network, employee network, both are in different VRF or same VRF?
Which one?
In your diagram, which you have highlighted, IoT network, employee network. So these
same
are
VRF, same VN. They are in the same VN. They are in the same IoT VN.
Okay.
Right. So
employee network.
Employee can be in a different VN. Let's call it employee.
No. I'm talking about VRF.
Employee VN VRF, same thing. Like employee VRF is a different, IoT VRF is different.
So, so that means that both VRS are able to communicate with each other?
Based on the configuration that you have done, yes.
But but by default, one VRF will not communicate with other. That is the logic behind.
Correct. That's why we have the concept of handoff. Like I'm saying, it will be a little bit, again, technical discussion, so let's not go there, but it is possible. It is up to us if we want two VNs to communicate to each other.
Sir, Surendra sir. So this removes the utility of this static and dynamic VLANs also.
Yes. Actually, dynamic VLANs where the VLANs are assigned automatically, yes, based on the user MAC address or the username password. Yes, that's correct. That is correct. Again, let's discuss more, and you will get more clarity as the content progresses. Like, not a lot of things will get clear right at this point, but the main point is that we can have the separation between different types of network. We can have the separation between different types of networks such as IoT and employee. We can configure the policies in such a way. We can do the configurations in such a way that they can communicate to each other, they cannot communicate with. In fact, I can make them part of the same VN, and still I can configure the network in such a way that they will not communicate to each other. That is also possible. Again, a lot of possibilities are there. Again, these things will get clear as our content progresses. These things definitely will get clear. At the moment, we are just talking about what functions we get, what facilities we get when it comes to the software-defined access.
So at this point, we can consider it like a person who is on a VLAN 10, and if they are just roaming around somewhere in the different locations, so there would be not any kind of problem.
Yes, the person will still remain the part of VLAN 10. The person will still have the same gateway IP address. In fact, the gateway MAC address will not even change. Right now, there will not be any ARP process or anything. So user roaming can be handled well within the SDA solution without any problem. Definitely.
Okay, only just like if the like something like I'm just giving a like an example, like suppose like in a different floor, VLAN 10 is not configured on that particular switch. So would it be the part of that VLAN or nothing like that?
No. So the DNA center will configure if the user is part of a certain VN, like let's say for example we have a user that belongs to the HR department, right, or maybe the IT department. And we have configured, let's say, for example, on the DNA center, we have configured the VNs and everything. We have done all the proper configurations. VLANs will not be there onto the switch, right? On the switches, VLANs will not be there. Once the user connects itself onto the port, once that authentication process actually happens, authentication process happens, then the VLAN will be pushed onto the switch. The port will be made part of that VLAN, and then the user will be allowed to access the network resources.
In a different floor, there is no configuration of that same VLAN, which is using on a different floor.
Switch that is connected on another floor, right? And again, that switch is being managed by the DNA center, and all the SDA concepts you are using onto that switch. Then it will do all the necessary configurations automatically. If not, then you have to do it yourself.
Okay, I'm just in the traditional network. We are not. Supposedly, it's not identical situation that they are able to use the access if it's a part of VLAN 10. If it's going to a different floor, so if there is no VLAN 10, it's configured on that particular floor switch. So that would be not. It will not happen. So I am just asking if you are saying that the user roaming here and there from this floor to that floor, so there is no impact.
VLANs will be created automatically. If again, if you are using in your campus area network the SDA solutions, VLANs will be created automatically.
Okay, got it.
Right. Which of course we'll discuss more later on. Let me quickly summarize it. So Cisco SDA solution. Cisco SDA is an enterprise network solution for intent-based networking. Intent-based network views the network as a single system. It translates and validates the business goals into the network and returns the actionable insights. Basically, here the network administrator, here the admin is going to define its intent. Admin is going to define what they want to do. They will define their intent on the we will say the controller, and the controller is going to take that intent. It is going to convert that intent into the valid configurations, and it will push those intents onto the devices, and based on those configurations the devices will start behaving. To achieve that, we require two components. One is like campus fabric and the DNA center, catalyst center. So Cisco campus fabric in a traditional physical network, the traditional physical network connecting the LAN devices such as routers, switches and everything is now known as the underlay network. Here we have our underlying infrastructure. Here we have our routers. Here we have our switches. Here we are using cables and everything. We have configured some protocol to make the reachability between all of them. This will be known as the underlay network. And the overlay network is basically a logical network built on the top of the underlay network. This overlay network is built with the help of the tunnels. Different types of tunnels such as like VXLAN tunnel, Lisp, and those things will be used. An overlay network is referred to as a fabric. Fabric in SDA term, fabric typically means the overlay network, and is logical topology that is placed on the top of the physical underlying infrastructure. So you can have any type of physical topology, it doesn't matter, as long as the devices are reachable to each other. As long as the devices are reachable to each other, you will notice that the DNA center will be able to push necessary configuration to build these overlay tunnels. And once the overlay tunnels are built, it will look like the traffic is going from this device directly to this device, because the traffic is moving via tunnel, and from the tunnel point of view, one end to other end is just one hop. The intermediate device information is not visible. So the traffic will arrive on here. It looks like the traffic is going directly from one edge device, from one switch to another switch, because the traffic is moving with the help of the tunnels. So underlay, overlay, which is like campus fabric. Campus fabric is the overlay network built on the top of the underlying infrastructure, and which is being managed by the Cisco DNA center or the catalyst center. Again, same thing repeated. What is the use case? Building on the foundation of the industry leading capabilities, Cisco SDA can now deliver key business driven use cases that realize the promise of total like it will reduce the total cost of ownership. We get like these following benefits: increased visibility. We can determine, create, apply, monitor the policies. Zero trust security for the workplace. That means we do not trust any device in the network. Each and every device should be properly authenticated, authorized, and then it will be granted the network access. User mobility can be handled properly. Guest segmentation can be done. We can integrate the IoT devices. We can put the guest users in a different VN. We can put the IoT users in a different VN. They will not be able to communicate to each other. We can create the policies based on the same. We can do all sort of monitoring and troubleshooting from the DNA center, and we can also integrate our traditional data center branches, or we can connect the SDA branches, we can connect the non-SDA branches. We can also we nowadays also have the option to add some external services such as cloud services as well within the DNA center. Later on we will see what external services, when we explore our GUI, then we will see what external services we can add in our DNA center. These are some benefits that we get of the software defined access network in our production environment. Again, repeating same thing, like these things we have already covered. It's not a cost-effective solution. That's also you have to consider. It is not a cost-effective solution. Building a software-defined access network is not a very cost-effective solution. It will cost you a lot, at least in the beginning. You have to purchase the DNA center. You have to purchase the supported devices. If you already have the devices, then you have to migrate it from the classic to the SD-WAN. If you do not have the compatible devices, for example, you are using old access points. If you are using old wireless LAN controller which are not compatible with the DNA center, then you need to purchase the new access point. You need to purchase the new wireless LAN controller, new routers, new switches. So it's not a very cost effective solution actually, not at least in the beginning. But as like in the longer run, like 3 years, 5, you have to pay for the subscription. Don't forget about the subscription. Don't forget about the license. We'll talk about the license later on. You need to purchase the licenses. If you don't purchase the license, you will not be able to create the VM. The point is that when it comes to implementing the software-defined access network, it is not a very cost-effective solution, not at least in the very beginning. But when you talk about like from 3 to 5 years point of view, so overall, like it will save approximately, as per what Cisco says, it will save approximately 67% of time in provisioning the device, 80% less time in resolving a particular issue, because we can use the artificial intelligence and machine learning capabilities of the DNA center to actually to find out the issues and everything. As per them, I'm not saying it, as per them, the 5-year return on investment is approximately 462%. Like the amount of money that you spend in tissue, monitoring and all those things, like the 5 years like return of investment, as per them actually, it's like 462%. Since we have a unified policy for our wireless users, everything is being managed from the DNA center, identity service engine and all. They say that there is approximately 48% reduction in the impact of the security breaches. Total cost of operation is reduced by 45%, more efficient. This is their, from Cisco point of view, these are the advantages that you get if you deploy the DNA center in your production environment, and which is quite correct. From the cost point of view, I can't commit like from 462%, but from overall cost point of view, from overall the amount of money that you spend on network operations and everything, that basically definitely that will the amount of time, the amount of money in a longer run definitely will reduce, but not like when we had to deploy the network right away. It's not going to be a very cost effective solution. Yeah, it's basically on the customer if they opt for the DNA center solution or not. So it's, in short, basically the software-defined access SDA built with the help of the DNA center. It will allow you to improve the user experience. It will allow you to manage the network properly from one centralized point, and you will be able to create the policies. You will be able to create the VMs and everything from one centralized point. Yes, eventually you will move. Like if you are still using some product, some offering from Cisco, eventually you will move from that offering to the DNA center, to the Catalyst center. Such as, for example, in a modern day network, we still use this thing called prime infrastructure. So sooner or later, since by the end of they have already announced the end of sales for the prime infrastructure, they also have announced the end of support for the prime infrastructure. So sooner or later, you will move from the prime infrastructure to the Catalyst center, to the DNA center. So they say like don't migrate right away. You migrate like in a step. Like if you have existing infrastructure, you can migrate it to the Cisco DNA, Cisco SDA, and if you are going to build a complete new infrastructure, you can from the scratch. You can, well, basically both the types of deployments are supported. For the new networks, we can deploy the new networks with the help of the Cisco SDA DNA center. And if you are having like existing infrastructure, that can be migrated to the Cisco SDA as well. If you have a traditional branch, that branch can be migrated to the SDA branch. And if you are building a new branch completely from the scratch, that you can build around the Cisco SDA solution as well. They can do that. Again, we will talk about it. We will see how the migration happens. Like, what are the steps that we have to take when it comes to migrating from the traditional to the SDA. What things we should migrate first, what switches we should migrate first. They do have a migration guide actually. If you want to refer to that, you can refer to that. We will take a look at that guide later on when we start our DNA center. So we'll talk about it, like how can we migrate from like existing to the SDA, but they have the option. They say that with minimum disruption to the users and the connected devices, existing infrastructure can be migrated to the software-defined access infrastructure.
Sir, sorry to interrupt. I'm able to see there is a ice in the prerequisite. So, is it really needed for deploying SDA?
ICE, na?
Yeah.
Again, point remains the same. If you want to enforce the policy, like the group-based access control and those things, yes, definitely.
Okay, noted. Thanks.
Yes. So they say that if you have a complete new network, you can go for things such as macro segmentation, micro segmentation. You can do like you can create the VNs, you can create security groups, scalable groups right from the scratch, and then you can deploy the software-defined access network there. Or if you have the existing infrastructure, you can just migrate the images. You can migrate the existing infrastructure from the traditional to the SDA in some steps actually, which we will discuss later on. So and the point of this slide is that we can either deploy a complete fresh network. This is like more like the greenfield deployment. Greenfield deployment basically means like we are going to deploy everything from the scratch. We are going to purchase the compatible devices, hardware, software, license, and everything. And then we are going to build a software defined access network from the scratch. And the brownfield deployment basically means like we already have our existing infrastructure and we are going to migrate from the existing infrastructure from the software defined, like from the traditional to the software defined access. So greenfield, brownfield, both the types of deployment is supported in our Cisco SDA. You can either deploy the branch completely from the scratch, or you can migrate from the traditional to the SDA, which again, we'll explore these options in our first layer, which is called physical layer. Yeah, so this is the basics. This is like, again, we already covered these things in the last class, but this is the basics, like why we need SDA, what is the advantage of using the SDA. We saw a little bit of like the demo of the DNA Center, this tool that we have. A lot of options are there. Throughout the content, we will explore variety of options of our Cisco DNA Center. Right, so the basic things are done. Now we can move on to the technical part of our Cisco SDA solution, and the technical part basically means like how do we build our SDA architecture? What are the things from the architectural point of view? What things are required for us to know how to just like we have in the OSI model, we have like the 7 layers, 5 layers. What things are there in our SDA architecture? We will talk about it. But before that, let's take a short break, 15 minutes, and then we will discuss about the that's the basics are done. Again, this is from the chapter number 1. You can go through it, and then like now we will talk about the components like of the SDA architecture. Okay. Now, from the since we are done with now the basic discussion, what is SDA? Basically, how the SDA is going to solve a few challenges that we were having. Now, let's talk about from the architectural point of view. Let's talk about like if we want to build a network around our SDA technology, what things we require, what things we need actually. So just like we have this OSI model, TCP/IP model, like we have that thing. In that, if you notice, we have this concept of like layers. We have like physical layer, data link layer, network layer, and all those things we have. Here, when it comes to architecture, when it comes from the architectural point of view, in the Cisco SDA solution also can be divided into few layers. From the architectural point of view, we have a total of 4 layers. Like if we talk about from the SDA architectural point of view, we have these like 4 layers. One is called like the physical layer, then we have the network layer, then we have the controller layer, and at the end we have the management layer. So we have the network layer, we have the physical. First of all, we have the physical layer, network layer, controller layer, and the management layer. And each layer, each layer has its own set of devices and or protocols and roles. So on every layer, we have the devices. Devices will be made reachable to each other with the help of some protocols. Then we are going to set some roles on the devices, and based on what role we have set on the devices, these devices are going to behave. So physical layer, network layer, controller layer, and the management layer. From the architectural point of view, we have these 4 layers here. If you have any question there, let me know. You can unmute actually if you want to. Right now, what is the purpose of the physical layer? Physical layer basically is at the physical layer. We will have devices. We will have all the devices. As the name suggests, the physical layer will have the devices, physical devices, and roles that we are going to set on those devices. Then the network layer will be responsible to deal with the underlay and the overlay. We have the devices now. Once we purchase necessary devices, then we are going to make these devices reachable with the help of some protocols and all. Basically, we are going to build our underlay network, and then we are going to build the overlay network on the top of the underlay network. So the network layer is going to manage the underlay and the overlay network. Controller layer, like our DNA center, and of course identity service engine, WLC. Controller layer includes like the controller, how to deploy the controller, where to deploy the controller, how to make the controller reachable, how to access the controller, and those things. So controller layer includes controller that we use in the SDA, DNA center, identity service engine, and the fabric enabled wireless LAN controller. Management layer handles how to access the controller, like how the controllers are being accessed. Like we can use like GUI, or we can also use variety of APIs to do all sorts of things on the DNA center. So management layer basically deals with the management, how the controllers, how the devices are being managed. How are we managing these like controllers? Are we accessing this controller, this DNA center, this catalyst center? Are we accessing that from the GUI, or are we accessing it from the application programming interfaces? So we have the physical layer, we have the network layer, controller layer, management layer. We have, from the architectural point of view, we have 4 layers. We'll discuss about each and every layer, rules and functions and everything on all these devices. The very first layer that we have called the physical layer.
So
yes,
here,
yes, Shaman, yes.
so here layer means that logically it is segregated from each module to another module, or actually layer means we understand that something logical, or it is brick by brick setup. So here layering means that, for example, there is underlay, overlay, or the physical, logical. But here you see physical, then network, then controller, then access
No, this
management layer.
is
This kind of.
exactly similar to as the oversight TCP/IP model. Just like in oversight TCP model, we have the layers. We don't see those layers. We can't see those layers, but they are there from the architectural point of view. So when we build our SDA infrastructure, these layers, again, some things we can see, some things we cannot see. So for example, controller, we can see how the controller is being managed, like from the web browser or the GUI, the physical layer. So this is from the architectural point of view. Like it's nothing like we can't like say like, it is physical or like virtual or like that. It is from the, when we have to build the SD architecture, we have to build the SD architecture considering these 4 layers in point, just like the oversight TCP/IP. It will get more clear, once we start talking about each and every layer. So the very first layer that we have in our SDA is called the physical layer. SDA, software defined access, physical layer, which includes, the physical layer includes the devices and roles. SDA physical layer like includes the devices and roles that we set on those devices. And based on the roles that we set on the devices, these devices basically start behaving. So as the name suggests, physical layer consists of physical devices that are used to build the SDA network. Once we have purchased the necessary devices, once we have purchased these devices, we are going to assign the roles. Different devices are assigned different roles in the fabric, and they behave based on what role they have been assigned. Roles such as like edge node, control plane node, border node, WLC. These are the roles. These are the roles that we set onto the devices. So we have purchased the few devices, then we are going to assign the roles on the devices, roles such as, for example, edge, control plane, border, and all. And based on the roles that they have set, these devices are going to behave. Based on what kind of rules we have set, based on the rules that we have set, these devices are going to behave. We'll discuss about each and every role one by one. But first, let's purchase the devices. First, let's have some devices at the physical layer. Let's see what devices we can purchase, what devices we can use at the physical layer. Then we will talk about the rules. You can't just purchase a random device. You cannot just purchase a random access point, random WLC, random switches, random routers. You can't do that. Whatever devices you purchase, whatever devices that we are going to manage via the DNA center, whatever devices we are going to use in the SDA solution, those devices should be from the compatibility matrix. Here is the SDA compatibility matrix. You can just search SDA compatibility matrix. You can just search the SDA compatibility matrix, Cisco software defined access compatibility matrix. You can just click on this compatibility matrix. This you can just click on that. I'm dropping the link in the chat. You can just take it from there as well. So here is the link. Again, you can't possibly memorize what devices are compatible, what devices are not compatible and all. So here is a basically a website that they built, and this website is going to let you know, this website will let you know what devices are compatible for the SDA, what devices are not compatible for the SDA. Right. So once you visit this website, you have to say, is it a new deployment or you want to do the upgrade? You can't upgrade from one version of the DNA center to the other version directly. You can't do that, So let's first talk about the new deployment. Let's say we want to deploy our SDA fabric from the scratch, and let's say it's a complete new deployment, right? So let's click on this new deployment button. I will click on this new deployment, then release. What release we are talking about? Like we have 2.3.7.4. This looks like to be the latest release that we have of the DNA center. However, Cisco recommends 2.3.5.5. This is the recommended release, right? Again, recommended releases are those ones that will have less number of bugs and everything, like most tested, most utilized image. So when you have to deploy the DNA center from when you have to deploy the SDA network from the scratch, it is a greenfield deployment, a new deployment. You have to choose what device actually, what version of the DNA center you are using. And then right here you can set you have to choose the role, like for what exactly you are going to use this device. Like I don't know about any role. I do not know about any role. So I click on the all button, and I will click on submit button, and it will list all the devices. It will list all the devices that are compatible with the Catalyst Center 2.3.5.5. So if you are using Catalyst Center 2.3.5.5 in your production environment, if you have gone for this solution, the ICE version has to be Identity Services Engine. The version has to be, recommended one is 3.2 patch 2. However, these are the versions that are supported. These are all the ICE version, Identity Services Engine versions that are supported with this release of the Catalyst Center. Anything outside this will not be supported. So for example, proper ICE version along with the patch. So you can't just go for ICE version 3.2 and patch 1, So whatever is written here, you have to just go through it. These are the compatible versions of the Identity Services Engine with the release 2.3.5.5. Not everything is supported. That's what I'm saying. Then we have these Catalyst 90 to 100 series switches that we can purchase and install. What models? These are the models that are supported of Catalyst 90 to 100 series switches. And then recommended software version is iOS XE 17.9. However, these versions are also supported. Then you can go for Catalyst. Forget about the role. No need to worry about the roles. 9300 series switches are there. 9400 series switches are there. 9500 series switches are there. you have to be very specific. Industrial Ethernet switches are there. Catalyst, Cisco Catalyst IE, industrial Ethernet switches, rugged switches, which are created for hostile environments, such as like factories, such as like a place where the temperature is very cold or very hot, something like that. So these rugged switches, there's a dedicated product line for the same. So industrial Ethernet switches are there. 3850 is also supported. 3850, 3650 is also supported. So if you have an old 3850 or 3650 series switch platform, that is also supported. You have to make sure that you have installed a recommended release or maybe the supported release of the software onto that device, but these switches are still supported. Scroll down, routers, Catalyst 8000V, 8200, 8300, 8500, series edge platforms. These routers, basically these devices are supported in the DNA center. And then you can just scroll down all the way to the rest of the devices. I'm not going to do that. For example, you want to know about wireless, so just click on the wireless button. So I want to know only about the eyes, so only eyes. I want to know only about the wireless, so click on the wireless, and it will show you like with this release of the Catalyst Center, DNA Center, what wireless platforms are supported. So we can use 9800 series wireless platform. When it comes to wireless, this is the WLC. 9800 series WLC, 9800 CL Cloud One is also supported. These are the models. Recommended release, supported release, 9800 embedded wireless controller on 9800 series switches. So Catalyst 9800 series switches, they come with the function that we can run the WLC on the same device itself. So if you have a Catalyst 9300 series switch, you can install the WLC image on that 9800 onto that 9300 series switch, and you can take the benefit of the SDA from there as well. Embedded wireless controller, EWC, embedded wireless controller, supported on 93, 94, and 9500 series switch platform. So this is the 9800 series WLC, and this is like the 93, 94, and 9500 series of switches. Embedded wireless controller is supported with this release. Wi-Fi 6 access points, 9105 series access points are supported. 9105 series APs are supported. Then 9115 series APs are supported. These are basically the APs that are supported. You have to be either you can run AirOS or you can run iOS XE. These are the models. You have to be very specific. This is wireless 9162 unified access point, Wave 2 access points like old 802.11, AC Wave 2 access points such as Aeronet 1800 series, 2800 series, 3800 series. Then heavy duty access point 7. These are the series of the APs that are basically supported. These are the series of the access points that are actually supported. Point I'm trying to make is that you can't just go ahead and purchase a random device. The device has to be from the compatibility matrix. The device has to be from the compatibility matrix. You can visit this website. You can just click on the deployment, and then you can just once you click on that, you can just click on submit button. Sorry, all, and you can click on the submit button, find the support, and then purchase the device accordingly. If you already have, let's say for example, a 3850 series switch, if you already have a 3650 series switch, then all you have to do is just upgrade the software version to the supported one, and you will get the benefits of it. Why? We will talk about it. Just in a moment, we will talk about it. So some old switches are also supported. Some old switch platforms are also supported. Some old switch platforms are also supported. Some old switch platforms are also supported. 3850, 3650s are also there. Why? We will just talk about it just in a moment. And then if you want to upgrade, since you want to upgrade from one version of the DNA Center to other version, click on the upgrade. Let's say for example, you are running an old version of the DNA Center, right? So let's say for example, you are running let's say version 2.1.2.4. This is the version of the DNA Center that you are running. you might not be able to upgrade directly from 2.1.2.4 to 2.3.5.5. You might not be able to do that directly. So you will click on this 2.1.2.4. This is your current release of the DNA Center. You have to upgrade from 2.1.2.4 to 2.2.2.8. That's the only release supported, right? So you can upgrade from here to here. And then you will upgrade from 2.2.2.8, 2.2.2.8, you can upgrade to 2.3.3.7, and then from 2.3.3.7, you can upgrade to 2.3.5.5. Then if you want 2.3.5.5, you can upgrade to the other one. You have to do steps upgrade. Once I upgraded, like, we were running like, very old 1.3 DNS Center. So I had to upgrade it to 2.3.5.5 latest version. I have to go through like, I believe, if I remember correctly, I have to go through like four upgrades. Like I went from one to another, then one to another, then one to another, then finally we were able to reach to this 2. So it's not like you can just jump like one to the other directly. In fact, if you go here, right here at the very top here, you in the DNA Center, you go to at the very top, you go to the software management, click on this. It's, by the way, it's under system. It's under system and software management. You can just click on this cloud button and you can directly go from there as well. Here it will show you. Like what release of the DNA Center is available, and you can download that release and install that release actually. But again, that release, it will not be like if you are running on 1.3 point something, it will not directly let you go to 2.3.2.3.5.5. It will not directly let you go through that. You will go from 1.3 to maybe 2.1, then 2.1 to 2.3, then 2.3 to 2.5, something like that. This is not possible. So even the upgrade, when it comes to upgrades are like a step-by-step upgrades. It's not like you can go from directly one to another. And then if you are upgrading from here, if you are upgrading from like 2.1.2.4 to 2.2.2.8, click on submit button, and these are the devices compatible with the release 2.2.2.8. So any device in your production environment, if they are not running on these releases, it will just not work. So when you upgrade, when you upgrade from one DNS Center release to another DNS Center release, first make sure that the devices that you have in your production environment, they are compatible with that release. There might be certain devices that are not compatible with this release. So find out if you are having, let's say, for example, a 9200 series switch, is that switch running proper software version or not? Otherwise, once you do the upgrade, DNS Center will not be able to communicate with that. It will just show unsupported, unmanaged. It will show you that. No need to memorize anything. Just visit the website. Either click on the new deployment or click on the upgrade. Find out if you upgrade from one release of the DNS Center to the release of the DNS Center, what software version we require on the devices. Then upgrade these devices first. Then you do the upgrade from one release of the DNS Center, Catalyst Center, to another release of the Catalyst Center. And if it's a complete fresh deployment, just go from here. Now, why these devices only? Why only these devices? Why only these devices are supported? Why not the traditional 3750, 2950, 36 is there, 45, 47? Why those like devices are not supported actually? The SDA capability is actually programmed in these devices. SDA capability, the compatibility with the DNA Center is basically programmed in all these devices. For that, we need a programmable chip. We need a chip that we can program as per our requirement. We need a chip where if some new technology is there, we can basically push the upgrade, the firmware upgrade or the software upgrade onto the device, and we get that functionality. Unfortunately, these devices, 2950, 3750, 45, 46, 47, these old switch platforms, unfortunately, they do not come with that chip. All these devices which are compatible with the DNA center, all these devices, they come with a chip called UADP. There is a hardware, there is a chip, there is an application, a specific integrated circuit on all these devices called UADP, Unified Access Data Plane. UADP is a chip. It is more like the yeah, it's basically a ASIC. It's basically a chip on all these switch platforms, on all these devices, that allows us to have the SDA capabilities. If a device is not having this UADP chip, the device cannot be programmed for SDA. And what do I mean by program? Program, I mean like Lisp, VXLAN. 3650, 3850, they do have that chip. 3650 series switches, 3850 series switches, they do have that UADP chip. When 3850 series switch was launched, it was launched with that UADP 1.0, if I'm not wrong. The very early release of the UADP version 1.0 was there in that, and because at the time when this 3850 was launched, I believe the SDN was still there in the market. So Cisco had the idea that sooner or later, like, things will go to the software-defined networking. So they created this specific chip and they made it programmable. By programmable, I mean that later on, these 3850 series switches are very old switches. Like, they came in the market like very long time ago. 3650 are very old switches. They came in the market like long time ago. But both these switches, they have that UADP chip. That UADP chip is programmable, and by programmable I mean that when Cisco saw that software-defined access SDA concept, the DNA center concept, we can actually now push into the market. They can just release a software upgrade. They can just release a firmware upgrade, and they can program the SDA capabilities onto these switches, such as, for example, like, VXLAN functions, such as Lisp functions. They can basically integrate onto those devices, and they did that. Why do you need specific software releases? You need specific software releases because these specific software releases come with the commands and everything regarding the VXLAN, command regarding the Lisp and all those things. So if you do not have a proper hardware and you do not have a proper software, your devices will not be compatible with the DNA center. And by not compatible, I mean, it's not like DNA center cannot manage. If I have a 3750 series switch and I discover that 3750 series switch on the DNA center can still communicate with that 3750 switch. DNA center can still show you these kind of things. It can still show you these kind of things about that switch. But that 3750 series switch cannot be made. You will not be able to make that 3750 series switch part of the fabric. You will not be able to take the full benefits of the SDA. DNA center will just more like be a management tool for that 3750 series switch. This switch does not come with that chip called UADP, Unified Access Data Plane. So since it still supports things such as, for example, SNMP, we can still retrieve variety of information from the switch on the DNA center. DNA center can still send a lot of SNMP messages, can retrieve variety of information. A little bit of management we can do from the DNA center, but full-fledged functions such as like creating the fabric and everything is not possible.
Sir, Surendra sir, I have a question.
Yes.
So, as per you, like this 3750 will not comes up. I mean, doesn't carries this UIDP. Hence, we will be able to see this device 360 kind of features, right? So, if I have third-party devices, is it the same thing? Like I can see the device 360 in the
if that device is supported of like things such as SNMP, because this DNA center can use SNMP as the protocol to send queries to SNMP traps and those things like messages to the devices. So it will still be able to retrieve variety of information. It will more like be a management kind of tool, but you will not be able to push like information. You will not be able to create the fabric and those things based on the devices, but still you will get a lot of information of those devices.
Yes. Okay, only automation will work. Like sorry, assurance will work. Automation, all these things will not work.
Yes.
Okay, got it.
And again, what level of things will work, like how much like assurance will work, that might also be completely dependent on that particular device.
Understood, sir. Understood.
So we have telnet, we have SSH, we have SNMP. You know, these three protocols. We have telnet, we have SSH version 2, and we have SNMP. Apart from that, we have netconf and other things. So if the DNS center is able to reach to the device using telnet, SSH, if the DNS center is able to log into that device using telnet and SSH, it can definitely, if the DNS center is able to manage that device using the SNMP, definitely you get you will be able to retrieve the information from the device under the assurance tab. But again, that device will not be, that device cannot be made part of the fabric.
Okay, okay, got it, sir. Thanks.
Right. That UADP, that chip that we have here, that specific chip that we have here, the devices that we are using in the SDA network, they have to be from the compatibility matrix. They need a specific chip called Unified Access Data Plane, or UADP, so that they can be made part of the fabric, so that they can be defined with the rules. We can't set the rules if the device is not from the SDA compatibility matrix. We will see that. We'll see that if we have a device that is not from the compatibility matrix, the DNS center will not allow us to set the rules on the device. And if we can't set the rules on the device, basically the device is not part of the fabric. And if it is not part of the fabric, we are not getting the functions of the software defined access. All the Catalyst 9K series switch platform, 92, 93, 94, 95.
Sir.
Yes.
सर ये ASICs हैं, ये switches में required है.
Yes, on all the devices. On all the devices, that has to be, that has to be compatible, that has to make compatible with the device. So mostly, like, yes, since we are using the DNS center for managing the switches, so yes, those switches must have this chip called UADP, which is there, which is already there on all the modern day switch platforms, on all the modern Catalyst 9K series switch platforms. They are there. In fact, the upgraded version of the UADP is there actually.
Okay.
So what about the routers? This ISR 443K and 4400 and all those also have that chip?
Every device that is compatible, it will have some sort of those kind of functions. Those functions can be built on the device, like if it is possible. Otherwise, there has to be a a particular chip. Like let me show you a document regarding the same. Let me search this UADP.
I am asking about the routers.
If the routers are supported in the SDA, yes, they will have it.
Okay.
Let me show you here. So if you search like UADP application specific integrated circuit, so what exactly is there? What exactly is this UADP and all? They have explained like why do we need like application specific integrated circuit? What is like Cisco UADP? In Catalyst, in 9000 series switches, like all the 9000 series switches, basically they come with that function. Mostly it's for the switches, because in the routers and the other devices, the functions can be embedded in some different ways. If you scroll down, like they will explain you like what is like UADP, what functions are there. So UADP 1.0 was there, then 1.1, 2.0, 3.0. Basically, they have upgraded the versions of the UADP, and currently we are running on UADP 3.0. Specifically, this concept is specifically for that particular chip, for that particular switch. On the routers, on the now when we talk about like ICE, when we talk about ICE is like a security appliance. It does not require that kind of chip. For example, when you talk about like firewall, like the DNS center can still connect to the firewall and do some configurations on there as well. So it does not require for the same. When it comes to like routing functions, when it comes to a router, when it comes to the router, like routers already come with the VXLAN and those functions. So it's more like a software thing. So the point remains the same, that whatever devices that we are using, specifically because the SDA solution is more for the LAN side, and in the LAN we mostly use these like switches. This UADP is specifically for like switches. And in other devices, such as, for example, like routers, the VXLAN list, those functions can be natively built on the software itself, like the routing software itself. Remember that switch already, when it comes to switching, switches already have the ASICs. They do all the functions based on the application specific integrated circuit that they have. And now they have this thing called UADP to have additional functions such as like VXLAN, Lisp, and those things. Here. Here. It's a better hardware performance. It's a better hardware performance and increased software flexibility. Provide okay, fine. The application. So it is hard not to agree that the success of Catalyst 3850 is due to its ASIC. In 2013, they introduced Catalyst 3850, 3650 series switches, and then these switches they come with the UADP chip. Here, UADP, like now we have 2.0 mini, which is there in Catalyst 9028 series devices, 2.0, 93, 2.0 XL, 3.0. We have like upgraded version of the UADP. Earlier, we used to have UADP 1.1, 1.0 in 3850, 3650. So like we do have, like the main point is that if you want to get the functions of the SDA on the Catalyst switches, you need to have that particular dedicated chip called the UADP. If you have that chip UADP, you will be able to program the switch to have support of the VXLAN and Lisp, which basically is available on these 3850, 3650, 92, 93, 94, 95. When it comes to routers, it's more like a software function. Just like AI, GRP, OSPF, BGP, these things we can implement on the iOS itself. Those things can be implemented, the VXLAN and those commands can be implemented in the iOS itself. But here on the switches, we need a specific hardware for the same. All these switches, all these platforms that you have checked from the compatibility metrics, all of these platforms, they do come with that support of the VXLAN and Lisp functions. Here. These UADP chips that we have, these UADP chips are programmable. These UADP chips are programmable. Modern day switches, they come with the updated version of the UADP, but old switches like 3850, 3650, they also have the UADP chip. So that's why they are compatible with the SDA fabric for certain roles. Not everything might work, but they are compatible with certain roles. These chips are programmable, means like Cisco can push a firmware upgrade on these switches to support additional functionality such as, for example, VXLAN. So if you go for the old 3650, 3850 series switches, they do not have the support of the VXLAN. You have to upgrade the image, you have to upgrade the firmware, you have to upgrade the software, then you will get the support of the VXLAN functions on the 3650, 3850 series devices. If you're deploying the things from the scratch, modern day SDA network in a greenfield deployment, we will mostly see Catalyst 9K series switches. They have the updated version of the UADP. They run the iOS XE. But in the old switch platforms also, we have the support of the same. Specifically 3650, 3850, these two switches, they do support this concept of like VXLAN. Why? Because they do have this earlier version of the UADP, which was later programmed by Cisco to support additional functions such as VXLAN. So if you have an old version of the 3650, 3850 that you did not upgrade the firmware and the software, you will still see that the VXLAN commands are not there. Okay. Now, before we proceed any further, let me show you how can you access, how can you explore this dCloud DNA Center. So again, since still like we are still talking from the theory point of view, you can explore this DNA Center from the D
Surendra,
cloud. Yeah.
this DNet doesn't support Nexus devices like 93180.
Nexus switches are not there, as per my knowledge. It's not there. You can check it here, although I don't think Nexus is there actually.
Doesn't support Nexus. Doesn't
It is
support.
not there. Yeah.
Only
Nexus is not
Catalyst
there.
devices. Only
Yes,
Catalyst
yes.
devices.
Catalyst devices running on iOS XE actually.
So the Catalyst device like C8200, C8300 will it support?
Find it from the compatibility matrix. Check it from the compatibility matrix. 8000 series switches, 8000 series devices are there, but those more like they are there. Some 8000 series devices are there, but again, you have to check it from the compatibility matrix for the support.
Yeah, just show us how to create a login in that DNA which you're showing, the D cloud.
There is no
Can you
need
show
for
us?
that actually. There is no need for that. You just go to the D cloud and just search the D cloud. Just click on this D cloud here. You have to log in with your Cisco credentials. So if you have the Cisco credentials, well and good. If not, then you can create a Cisco credential. This D cloud, you will log in like here. You will click on login, and here you will log in with your Cisco account. Let me quickly log in with the account. Once you log into this account, once you log into the Cisco D cloud, this is again for the demo purpose. So they have like a lot of product demos right here. So just once you go to the D cloud, let this load. Here, you can go to the catalog right here on the top. You can click on the catalog button. So this is like how the D cloud page looks like, and then you can go to the catalog. In the catalog, like you can click on here D cloud. Then you can click on here instant demo. Here, click on filter the D cloud and instant demo, and you can scroll down. Either you can scroll down. These are a variety of demos that are available. SD-WAN 20.11, 12, whatever it is, 20.13 and all. You can scroll down. Either you can scroll down all the way till you find that Catalyst Center or the DNA Center. Here, Cisco DNA Center, Automation and Assurance 2.3.5.0, whatever it is, instant demo. Right. So here is the related documents for the same. You can click on the view button. So it will open this kind of page. It will open this kind of page, and the document, click on the related document. Here you will see the user ID, passwords and everything in the related document section. Right, so click on that. It will open the related document regarding that particular release, assurance, provision guide, and those things. It will open, and there will be there will also be like username, password will be written somewhere here. Please use the newer version of this demo. You can also click on that, so it will redirect you to the new version of this demo. Same thing. By the way, the password here, just if you click on the related document, you can scroll down and you can see the password is demo. Where is that? Demo and demo 1234 exclamation mark. So just use that username password here and you will be able to log in. Right, so demo 1234 exclamation mark, and just click on the login button, and it will just log into the DNA Center. And then basically I have bookmarked it, so I don't need to do it again and again. I just can open it right away. Right, so this is the same thing. Now they say that you can also you can check if available, you can check the demo of the newer version 2.3.5 maybe. So you can search in the D cloud if you do have like a new version demo. Otherwise, you can explore the things from here itself. It's basically the same thing, same all the things. Right, so you can explore the options. You can explore the things from here. You can explore the DNA Center, D cloud, and all those things. You can explore from here. right? You can search from here as well. You can search the catalog for the DNA Center for the whatever demo you want to look for. So you can either search from here or you can just scroll down and until you see the DNA Center there. It's completely free, but again, this and here you can also not only you can not only have the read, but you can also do sort of like write things as well. For example, you can go here, you can go to, later on we will do it. You can go to the design, we can go to the network hierarchy, for example, and we can create it actually. For example, we can create a we can do the some sort of whatever things we will do in the lab, you will be able to repeat like a lot of things here itself. You don't need to open any sandbox or any devnet sandbox or those things. You can do it actually here itself, right? So this is the demo. So for the meanwhile, like you can just explore it, explore all the options that we have, just at least just go through a few tabs that you see here to find out different things. Throughout our content, we will keep exploring these options, all these things, but till then, like you can explore all these different tabs that we have like here in this DNA Center dashboard. This is completely free, no charges of it. It's more like a demo, so you can just log into your Cisco website and actually have the access of this dCloud DNA Center. And of course, you will be able to repeat a lot of things that we do in the lab. You will be able to repeat a lot of things here actually. I would say 50-60% things you will be able to repeat here actually. 50-60% things you will be able to repeat here. Whatever things we do in the lab, you will be able to repeat a lot of things here actually. Right, so again, all the devices that we have here, you can click on the devices here. Where is this? There are total 121 devices. You can click on these 121 devices and it will open the inventory. It will open the inventory of all the devices. It will open the inventory of all the devices that we have. These are these are all the devices that we have installed in different geolocations, different locations, their IP and everything. And you can click on any device. Just click on this device. I click on this campus core 2. If I click on this device, it will show me like, okay, it is a switch and hub, version is 17.19.1, and where exactly this device is located. This device is located in North America, USA, California, San Jose, and this location. This device is basically placed into this location. We will do that later on. We have placed this device into this particular location. The role of this provisioning is successful. This represents the state of latest provisioning operation attempted on the given device. So DNA Center was able to reach there and was able to push the configuration on the device. A role is core, health is 9, IP address. You can click on the device 360. You can click on view device detail. It will show you the detailed information about that device. And if you click on device 360, it will open the 360 view of that particular device. You can click on run command and you can run the commands right from here itself. So again, what I'm trying to say is that you can explore a variety of options that are available within the scope of this demo dCloud DNA Center.
Surendra sir.
Yes.
In here, like this CLI kind of thing that opens any command means like we use the commands on switches we can use here.
Yes, not here, not in dCloud DNA Center, no, but in real, yes. Here you will not be able to. Here they have blacklisted a lot of commands. Like you can't like say show version. The command is blacklisted. But in real, you will be able to do that.
Okay, in real, it's like it means this command runner is like we are accessing the switch in a normal mode, like in PuTTY or something.
Yeah, it's same like that. It's more like doing telnet SSH whatever in the background, and we execute the command, we get the output actually.
So in fact, instead of this SSH or telnet here, it uses netcon, right?
No, we'll talk about it when we discover the devices. We'll talk about it when it uses telnet SSH and when it uses netcon.
Okay.
So again, that command runner thing, basically we have under the tools command runner, and we can select a device from here, and we can run multiple commands at the same time from here as well. Like we can like show version, like we can run the commands right from here as well. So again, we'll discuss these different tools that we have later on, but So we can run multiple commands at the same time on multiple devices, and also a lot of options are there. The main point is that you just go through the DNA Center dashboard and explore as much as you can. Right, so first of all, purchase the devices that are supported for the SDA. Purchase the switches that are supported for the SDA, purchase the routers, purchase the wireless devices, purchase the access point that are supported for the SDA. If you already have router switches, wireless LAN controller and all these things, then make sure that they are running proper version of the software, iOS XE, make sure that they are running proper version of the software. Then only you will be able to take the full functions, full benefits of the software defined access. Now, since we are talking about the software, these switches that we are using actually nowadays, they run on this thing called iOS XE. iOS XE is very popular nowadays for both routing and switching. So we have iOS typically, and we have this thing called iOS XE. We also have iOS XR, but let's not talk about that. But we have, just to give you a brief idea, because we don't have that much time today. So we have this thing called iOS, and then we have iOS XE. Again, let's say, for example, there is a router. This is a router, and in this router, we are running operating system. So it's like, the operating system is running on the device itself. Like the iOS, the operating system is running on the router itself. The operating system, the iOS, is basically allowing us to configure things such as routing, such as switching, and all the functions. Basically, iOS is allowing us to do that. It looks like the iOS, the operating system, is running right on the box itself. The operating system, the iOS, is running right on the router, right on the switches, right on the box itself, and it is allowing us to do routing, switching, and all those functions on the device. On the other hand, means like it is the actual operating system that is running on the router and switches, allowing us to do plenty of things from one point. On the other hand, when it comes to like iOS XE, in case of iOS XE, the architecture of the iOS XE is in such a way that, let's say, for example, we install, this is a switch, and on this switch I install the iOS XE. In the iOS XE architecture, which we will cover in our next class, just to give you a brief idea, when it comes to iOS XE, any device that runs iOS XE, their iOS is not running directly on the box itself. iOS is running as an application. You can consider iOS running as an application. Just like you have your laptop. In the laptop, you have installed Windows, and you are actually running inside the Windows. You are running like EVE-NG. So it's like an application running on the top of some base operating system. What you could have done, you could have purchased, you could have installed, let's say there was a way that you can directly install EVE-NG on the box itself. That means you now will be able to run only one thing, that is EVE-NG. You will not be able to install other applications, because EVE-NG is the only thing that is now running on this particular device. This software is the only thing that is running on this entire device. But in the iOS XE, what happens? The iOS runs as an application on the top of some base operating system, which is actually Linux based. So iOS XE actually has a Linux based architecture, and on the top of that, it runs iOS as an application. iOS XE is the new version of the iOS that runs on Linux. So on the top of the Linux based base operating system, it runs the iOS as an application. Advantage is that the iOS is not the only thing running on this box now. Now we have the option actually to run other application. I have the option to run other applications onto this device. I have the option to run maybe some security applications. I have the option to run some other maybe if possible, then maybe Wireshark within the same. In some virtualized environment, you can say, in some virtualized environment, we are now having the support to run not only the operating system, but some other applications as well. Yes, like using the concept of guest shell, port group, virtual port group, and all those things. So the major, we'll talk more about it, but the main difference between the iOS and iOS XE, you will notice that in case of iOS is the only thing that is running on the box. But when it comes to the iOS XE, actually the iOS runs as an application on the box, on the route, on the switch, on the router, and it allows us to onload, like it allows us to upload, install, run other applications right on the box, right on the same, because router is basically it is a hardware that has a certain amount of RAM, that has a certain amount of CPU. Basically, it has some computing resources. So why we are not using this resource to run other applications alongside the iOS? Earlier, we were having just the iOS. That means iOS is running on the box itself, and everything is consumed by the iOS itself. There was no place to run any other application on the top of that particular operating system. So they changed it. They say that this is the iOS XE architecture. In the iOS XE architecture, we are going to have some base operating system, and the iOS, for example, itself will run as an application, and it can interact with the other applications. Such as, for example, we want to do some programming automation thing. That thing can be enabled on the box itself. We can enable this thing called guest shell, and right from there we can enable the programming capabilities right on the box itself. We can run the Python scripts. We can create the Python scripts. We can run the Python scripts right from the iOS XE box itself. We can do the coding and everything right from there. It can interact. This application can interact with this application. So once you run this script, maybe you will get the routing table of the router. Maybe you will, once you run that script, maybe you will get the VRF information of the router. So it allows us, basically iOS XE allows us to run different applications on the same box alongside the operating system, and then it allows us to basically interact with those applications. Like we can connect iOS with those like programming automation applications or security applications or some other applications that are hosted on the device. We can have the interaction with them as well. Even though we are only going to focus on the operating system, we will not focus on the other things that we can do. Maybe when we cover SD-WAN, there you will notice that we have an SD-WAN router that is running on the iOS XE. Here iOS is running, and right on this iOS we can deploy security application image, and we can have the security features right on the box itself. We do not need to purchase and install a new security application for the same. Again, so devices that we are having at the physical layer, they must be from the compatibility matrix, and they must run proper version of the iOS XE, so that there is a support of the software-defined access onto those devices. We will discuss more about it in our upcoming class. Then we will, once we are done talking about it, then we will talk about the roles that are there on these different devices.
What is the difference between XE and XR?
XR is for the service provider routers.
Okay, it is as it is same, that
commands.
and the application.
No, commands and everything are different. They run. Not sure about the architecture, but in XR the support of the commands and everything is a little bit in a different way.